I've worked a couple of almost 15 years in VMware, and after that I joined Redis to work on the drivers client systems team. I have primarily worked with clients the last couple of years, I would say, but I have an overall idea about the distributed applications and the web stack as part of the job that I'm doing. And today I'm going to try and entertain you on that topic as much as I can. I have to be honest with you. When I first started thinking about this talk, I tried to use the latest tooling, and you know the latest tooling is AI. So I tried to ask AI to write me a presentation because I'm a lazy programmer, and this is how we do stuff. And while it was actually outputting all the suggestions about the structure of the talk, about the topics, about different things I should mention, I realized that just about anybody can do that. And there would not be a lot of value for you to come here and just listen to what ChatGPT told me yesterday. So instead, what I did is I tried to compile a set of stories where I can talk about different stuff that I've run into during my career, and probably help you learn some lessons that I myself learned. But because it would not be honest to skip a lot of the information about client-server communication and client-side development, I have a bonus track, which is in the beginning of the session, which is basically telling you everything you should know about client-server communication and what you would otherwise learn from ChatGPT. Sorry about that. So, yeah. So the bonus track is basically the time where those of you who are more advanced may drink their coffee and have a rest before the actual action. And I will try to make it in 3 minutes. I drank my coffee, so it's possible. I've tried it, but it's going to be a lightning talk, a slide about a lightning talk. So, what is client-server communication all about? Obviously, you have a server. I started with the server because you have there all the basic business logic of an application. It's only fair for it to be a central place in our presentation. But the server itself is just providing you the options to consume a certain set of features. Several different entities could consume the same set of features, but that's not really enough for you to have an application. So you have a client that's actually consuming them. One or more clients are working with this server, consuming the features that the server is providing. Now, typically, the client and the server are not in the same process, so they have to communicate with some sort of remote method invocation mechanism. In today's world, where more and more applications are in the cloud, and we have these distributed applications working everywhere, Facebook, LinkedIn, all these applications actually have a huge layer of networking between the client and the server, where there's gateways, load balancers, security appliances, all of them working in some way to help you shape and route the traffic to achieve some sort of scalability, some sort of availability, and stuff like this. So there's a lot of things between the client and the server today. But if you think about it, and if you see this picture, it's obvious that the components within this picture beside the client, which is the appliance, the gateway, the server, they're all actually clients because they talk to each other. Whenever a server initiates a connection to another server, it's actually a client. That's what it does. So clients come in all sorts and shapes. And you could see very simple examples like the web browser. A web browser is actually a client of different types of applications which are loaded there, and it connects to the server to finish his job. But you have also native clients, such as all the applications in your GSM, like in your mobile. Most of them are clients because they contact some remote service. You have IoT, like your fridge. Your fridge, if it's IoT, it connects to a server, and when it sees that you've run out of X and orders in Amazon X, it basically is acting as a client.
You also have edge, like in cars, in machines, in factories. All these things are clients. And of course, I mentioned already that servers are also clients. So any device connected to the internet would eventually end up being a client at some point. What the client does, it connects to the server, it initiates the whole flow, usually does some authentication, not always, depending on the protocol, depending on the server, it could be assigned a session. These all are optional, but frequent components in the communication with the client. Then I mentioned protocols. There's a lot of different protocols, and this is like the topic of several different talks that you could have on this, so there's no easy way to condense it for me. Basically, depending on what you want to achieve, depending on what you are doing in your application, different types of protocols could be working for you. The responsibilities of the client: it needs to collect user input with all the caveats around it. It needs to display data in the best way because it receives it in some raw way. It has to display it in a way that's easier for the user. If this is a client which is a UI, you could also have API clients which synthesize the data in a specific object that's easier to handle for the client application. They also do a very important thing, which is handling the network. That is replies, network jitter, all the things that would happen during the communication with the remote server. It is responsible for them. Now, when I say UX, don't always think about UI. Any sort of interface, whether that's an API, whether that's a service, whether that's a terminal, they all have user experience. The user that consumes them needs to have the right user experience for them to work. I just did that. I'm not sure what happens. And of course, you have to choose the right type of clients. There are different types of clients. Usually, in most cases, the best type of client is a thin client, which is that's because if you want to spread, if you want to have different clients contacting the same service, you don't want to implement the same kind of logic in all the clients. You want to keep it. You want to keep it in the servers, in the business logic, and at the same time, the client should be thin. And not least, last but not least, it has to be secure, a client. Do you think there's something we can do about this? I'm not sure it's the screensaver because this is on. It may be that the connection is... Thank you. But about security, very quickly, it's very important because the clients are usually in a public network, in a public device, or your personal device, so they need to be very secure there. The easiest way to hack a system is through the client application itself. And we get to the stories. I did not manage to do it very quick. Sorry about that. It should have been a lightning talk. It became a talk inside the talk. But the stories are the fun part, I guess, at least to me. And I want to talk about a few things that I run into while I was working on in the different companies that I worked at. One of the things is, and this slide is very easily confused, so I'm going to try and put it in a very specific example so that you know what I'm talking about. Often, if you've worked developing a client, you should have been running into this issue, and that's probably the worst issue that I've run as a developer, when everybody just expects your part of the code to do all of the job. It's a distributed application. There's a lot of different components. There's servers, there's middleware, there's also other clients, and suddenly the people that see your application, they see the client because that's how they consume it. They consume it through the client, and they assume everything needs to be in the client because it seems logical. It's where you would put it because that's what you see. But of course, there's a lot of things underneath. And now imagine Facebook. Facebook has several different clients. Like you have a web client, you have an Android client, you have an iOS client. As far as I know, they're native, so they're different code, really. So everything that you implement in a client, in a single client, you have to implement it all the clients. And of course, if it's a UI feature, you have no choice because it's basically what you have to do. But, well, there's another slide that actually talks about this, so I'm not really truthful, but we'll get to that. What you have to do is, and that's just a message from all the times that I run into this problem. I usually ask myself 3 simple questions, or at least a couple of simple questions, but these are the ones that pop up in my head always. So the first one I already explained about, do other clients have to implement it, and can they avoid implementing it? If they could, then this is a business logic that you could put in the back end. Would it affect performance? Clients are usually run in a different machine. They're not in a server. Like if this is your phone, the hardware there, the network bandwidth that you have, they're much more restricted than the things on the back end in your server. So normally you would not want to do things in the client. And of course, there's the question about orchestration. Like if you have a complex system that does a couple of different steps, one after the other, the client is not the best place to orchestrate, especially if it's like a thin client in like a mobile device. Imagine you're driving in a train and you're booking your flight, and your client in your mobile device is actually orchestrating it. So it's going to one service, it's booking the first flight, it got the ID, now it's booking the second flight, and you go in a tunnel. And in the tunnel, you lose your connectivity. If the client was orchestrating all this, you leave the system in an invalid state. You don't know where it stopped. You can't, in some ways, resume it. You may not be able to resume it in many hours. So you don't want to do orchestration on the client, except in certain specific cases. So that's one story. But in the same time, there are situations where you would want to switch roles, like you would want the client to work more like a server and the server to work more like a client, again, depending on the actual requirements to your system. I'm going to give you 3 simple examples. There's a lot more, of course. These are the ones that I came up with after thinking a bit. The first one is something we were doing in Redis recently. We added to our drivers, the Redis drivers, we added client-side caching. This is a feature that allows you to cache some of the data that you would otherwise query the Redis database with and not hit the Redis database. It seems funky at first because what Redis often does is be a cache. So why would you be doing the same thing that Redis is doing? Well, obviously, those of you that know more about caching and have experience would quickly see that the good rule about the cache is it's as efficient, as close it is to where the computation happens. So you're basically doing a level 3 cache in your driver, and then you have a level 4 cache in your database. But essentially, your driver is doing what your server is doing, just to a smaller scale, of course. Another similar example, but all the way around, is how server could do the client work. In server-side rendering, when you have a huge system, multi-services system that has micro front ends, microservices with micro front ends, you may end up having to build the UI dynamically from the different services behind the scene. If you do it on the client, you have the same problems that I just mentioned about bandwidth, about computational power, and you may end up slowing down the UI. What you could do in this specific case is you could actually have a component on the server side that renders the whole UI for you before that, and just gives you the result, which would greatly speed up the building up of the UI. And of course, I mentioned client orchestration, and I said that it's bad, and I gave an example, but there's an example how, in some cases, you could actually want to do this. We had at VMware such example where we wanted the client to participate in the data path, because if we were to put a component to aggregate all the different requests that the client has to do and spread them around in all the servers, which is a better, generally speaking, a better architectural approach, we would have had a bottleneck there. So we wanted to avoid this bottleneck, and instead we asked the client to orchestrate the upload of the pieces of the files to all the different servers. having to pay the price that it may sometimes end up in a not very valid state, but there were ways to clean the state also. But this is an example of where you break the rule for some other reasons which are also valid. Now, about how fast your server is, and this is very important. This is my favorite slide because nobody understands it. So I'm going to test you. I have a candy, actually. The first one who says it understands, after I finish, I'm going to give the candy to you. So the moral of the story is, obviously, if you have a fast server, it doesn't really matter in the same time if you have a very slow client, because you don't see the speed in any way. The client is slowing you down. What I did is I used AI again, because, AI. And I asked it to just go there and make a comparison of all the most popular, most popular drivers for Java, for Redis. And I give it a huge prompt. And it ended up with something that looked nice. I don't know. Because it's AI, it's obviously not a hallucination. It's right. So we may be very trustful of this data. But what I did is I opened up the project it generated in order to come up with this data, and I just changed a small, well, not small, but part of the configuration of the driver that I'm maintaining, which is the latest driver. And you can see that it had a bit of an improvement, like 10 times, which I would say is good. And the moral of the story, I think I'm going to tell it to you so the candy is for me. The moral of the story is we don't want to consume things as the AI gives it to us, or a Stack Overflow gives it to us, or like any type of forum gives it to us. We want to know what we are using, because otherwise we would not actually benefit from the speed of the system. I guess the LLM that I used was not really very well trained about how to optimize latest driver for get and set operations, which I find interesting. But, this is the moral of the story. And then, this is more of a cautionary tale. And this is not extremely client-related, but I think that people that work on the client side or with the client side might run into it a lot of times. Because we often, when we go to any type of organization, a larger organization, because I'm not talking about small startups where there's 5 people and everybody's touching everybody's code and there's no boundaries there, so this totally does not concern them. But in larger organizations, there are these organizational boundaries that we're instinctively following because of our herd instincts. We want not to get into other people's work. And like if you work in the UI, you would like to focus on the UI, and you don't want to know what happens in the backend. And if you work on like the APIs, you do your APIs, you follow the best practices, the requirements of the organization, follow the security model and stuff like this. And sometimes we end up using things that we totally don't understand, like a black box. And this is actually bad. And this is really bad because the clients, they don't care about these boundaries. Customers, in terms of clients. I'm sorry, clients and customers is sometimes intermingled in my head. But the customers, they don't care about these boundaries. They want to use the application in the best way, with the best performance. And the fact that you did not open up and read somebody's code, they don't care about this. They want you to use it the best way. And this is how you should use it, by the way. There's no reason for you not to read other people's code. We have to be sure, because like basically these arrows here are just for example, but you can't do integrations, can't do extensibility without knowing how integrations are done. You can't do ecosystems without knowing how APIs are done. You can't do UI server communication without knowing how the server works. And it's both ways, by the way. If you work on the server, you kind of have to know how the UI works. It may sound irrational to you, but this is how it's consumed. So your job is not done the moment that you implement the feature and provide the API for it. you have to know that the user is consuming it properly. And you have to go to the UI folks and say, that's a good way to use my code, but that's not the best one. There is a better one. I've envisioned it in a different way. And it's totally normal. So don't be afraid to overstep these boundaries. They're imaginary, they're artificial. They're not there. And when we said APIs, these are some very crude, quick examples that I found out in GitHub. On top right, you can see how many times in GitHub people have basically abused APIs, because what they do is they use reflection to change the visibility of a field. And of course, if this is a unit test, I don't care. Nobody cares. But a lot of these are not unit tests. So what people do is, I don't like your API. I think I need to consume this method, although you've specifically spent the time to hide it. And it's a cautionary tale. There's two things to learn here. The first one is nobody is really forced to use your API as it is. They can use it whatever way they want. The second one is, if you find such a case, then basically you have failed. You have not provided to the person that's consuming you the best way to consume you. Either it's missing documentation, which would explain how to do it without reflection. Either it's the functionality is missing, but something is missing there, and this is why they did it. Don't always assume people are hostile. They don't want to do it just to mock you. It's just that they wanted to do it for some of their requirements, and they had no other way. And the other thing is, on the bottom right, you see how many hundreds of issues are marked as invalid. Invalid means somebody has been using the lattice driver in a way that it's not supposed to be used. Fair, fair. And I usually would go and say, I'm sorry, you're not using the driver in the right way. Close the issue, forget about it. But that's not the right way. You have to think about why they used it. Was it not very obvious how to use it? Was it that it was missing some functionality? Sometimes users are lazy. And in that case, you can't help them. You can't go and make them use it the best way. But if you can improve the documentation, if you can improve the API in some way, this is actually a pointer. Somebody went to your tracker and said, I was not able to use that. And you have to use this opportunity to improve your code. These are the 4 things that I mentioned just conversationally. And the last one, the standardize, I'm not saying about always using standards, but we have to make sure that our code is as, and also UIs, of course. All of the things that I say relate both APIs, user interfaces, everything that you could provide as a interface. They need to be in line with other similar APIs. That helps the user quickly adapt them, and overall, the user experience improves by doing this. And this is a controversial slide. First of all, a disclaimer, I was told that Spotify no longer uses this approach, exactly the same approach, but this is how it used to be a couple of years back when they created this YouTube video. You can scan the QR if you're interested. They spend some time explaining their process and stuff like that, but that doesn't matter. Assume this story about Spotify as an old one and not very latest, but it's used as an example of what I'm going to say. So when you do clients, there is a very sugary thing that you can end up doing, which is, I want to quickly solve the problem for all platforms. I don't want to write code for Android. I don't want to write different code for iOS than for web. I want to solve it for everybody. And this is where progressive web applications come. They promise you this situation where you do the code just once, and it's actually somehow modified or compiled, or depending on the technology, of course, because there's different hybrid technologies. You end up having one code for different platforms. And it's a good promise. It's a good promise, but it comes with a couple of trade-offs that you have to know about. I've personally worked on the bottom left part, which is the the mobile client for the vSphere suite. And the reason we initially chose to do this is we wanted to have exactly the same user experience in the mobile client as in the web client and everywhere. Basically, we wanted to have the same user experience because everything that is different in experience requires somebody to train the customers how to use it, or ends up being tickets in the end. They ask us how to do this, how to do that. So we wanted to solve this problem. We did a Cordova-based application. Cordova is a framework that gets your web application and creates outputs from it, different mobile applications, and you have the browser embedded in the application that renders this application. Something very similar was done with Spotify. They used iframes there, but basically the same. And now I think they're using React Native, which is a different type of hybrid technology that allows you to do the same thing. And yeah, so if we go back to the mobile client, where I can talk in length for many days, it did some of the things. So these are successful stories on the left, I would say, because we had a huge adaptation, a very rapid development process there. But it came with trade-offs, and you have to know that if you make this choice or if you participate in something similar, maintenance is definitely much harder, and debuggability, especially debuggability. Now, of course, it depends on the framework, depends on the platforms, depends on the process, but you can never test it easier when you have more components throughout the whole process. Like in our case, if we ended up with a ticket that in Android version, let's say, I don't know, 12, some version, and phone, whatever version, there's something as of a problem, what you have to do is you have to have the hardware, because that's the only way to reproduce it specifically there, if it's not shown somewhere else. So you have to have the hardware, you have to connect it to your computer, you have to enable debug mode, you have to have a browser there, sorry, you have to have a setup on your developer machine that allows connection to the Android device if we're working with Android. I'm not even going to mention iOS, which is much harder. I'm saying the happy path here. So you basically have to have several different components configured just to get to the point where you put a breakpoint somewhere and see what's happening. And it's really much, much harder. In the world of Redis, there's drivers that try to do the same thing, supported by our competitors. And I've personally had some experience with one of them. It just threw an error. And the error was, I can't continue. And because it's a hybrid driver, it basically has, on top of it, let's say Java or some other framework. And below that, there's a native part, which is compiled from Rust. And you have some way of communicating between them, which is the middleware. And that's all in the driver. So when you want to debug it, it's not that easy. These are really huge problems. Of course, I'm not saying they don't work. I'm saying there's a price to pay. Performance, nobody can convince me that the performance could be the same when you have an additional step. Like in the case of this driver that I'm speaking about, the data that you receive in Java had to go through a protobuf, so it's converted to data that the underlying Rust code could use, and then sent over the wire, again converted to bytes, because that's what most drivers do. So you have two steps instead of one step, usually how drivers work. And of course, funky UX in the case where you have a hybrid UI and partial code reuse, because if they're promising you're going to do code reuse, it's never the same. I mean, there's always, you have to put an if statement somewhere. You could not use the same UI for desktop and for mobile, for instance. I have an example here for disk control. You would want it to render differently. Just you don't have the space. And in the same time, if you render it on a desktop, you don't want to waste all the space. So there's always an if statement. So yeah, a bit controversial. And this is another cautionary tale from the time when I was in VMware. There was an application. I briefly mentioned that in the start of the talk. where the client had to orchestrate the upload of a file. However, the initial implementation of this solution was involving a separate component. Of course, there were some reasons to do that when they did it. First of all, browser back then allowed you to do plugins, which now is impossible today. But before, there was the option to do a plugin, and what you would do with this plugin is you have much more streamlined access to the system. And this allowed them to have a simpler JavaScript in the application, then start the flow of the uploading of the file from the plugin, and a lot of the actual file upload stuff, the breakdown of the file, stuff like this, all of it is done in the plugin. However, it meant that you have two components. And with the browser, that's three components. So what happens is our clients would get version 5 of our application. They will install the plugin from version 5, which is plugin version 5, and they will use it in browser, Chrome, whatever, 100, for instance. And then tomorrow we release a new version of the app, and we have a totally different compatibility matrix then. We have a new app with an old plugin because they would not install the new plugin because they already have this old plugin, and a browser that may or may not be new. So the compatibility matrix was just, I don't even want to remember these times. You don't want this happening. You don't want to have so many components you have to deal with. The simpler, the better. What we did is we removed entirely the plugin. Well, to be honest, partially because they stopped supporting plugins, and we had to at some point either way. But we removed the plugin. We moved to the new browser APIs that allow you native file transfers. And what we ended up with was a much simpler implementation that also allows us to use all the native browser capabilities and not rely on different components. Very simple, very fast. And I was quicker than I expected. This tale is actually very quick, and we'll have some time for Q&A. When I got to Redis and I was hired there, the manager that hired me said, "Okay, you'll be the maintainer, the next maintainer of this Java driver. Please go over these recordings where the previous maintainer is going through all the things that you should know." And the team was asking the maintainer this and that. And at some point, the maintainer actually asked them, "Okay, what do you think is the biggest problem the driver has? You've been there, you went to the tracker, you saw the issues, you've read everything. What do you think it is?" And our colleagues, they assumed it's some of the most common things that you would run into the tracker, like there was a problem with some clustering stuff, there were some connectivity retry issues and stuff like this. So they mentioned all of them, and he was like, okay. And then he came and said, I know there is a problem with the driver in the way that it handles data, because sometimes you get these, the responses come in a wrong order, and you don't deserialize the data, the right data to the right request. And then it's a huge problem. By the way, just a couple of months later, there was a story that a client that was using this driver run into this, and what happened is you would, one broker of stocks would send a request, and because the server would run out of memory in that specific moment, another broker would receive the response for this same request. So it's a huge issue. But what the maintainer, Mark, said was, this is the biggest problem. The biggest problems are issues that you know are there, but you can't reproduce, and you don't know what the problem is. And there are a couple of these. Why I'm saying this and why it's related to clients, because the easiest issues are the ones that you can reproduce. I would say I have my Friday mornings are dedicated just to prune them, because if you have reproducibility, it's an issue that you can fix in 2 to 4 hours. The biggest issues that I never have time for are these that don't have a reproducibility at all, or not easy one. And it's good to plan for them if you could, but they often just live in your tracker for a long time until somebody manages to help you with the reproducing the issue. And yeah, I was faster, not because of my lightning talk. I'm open to questions if you have any about everything, the world. I can talk also about melting. Yes?
Okay, thank you. How do you tackle problems that you know exist but cannot reproduce? Because I recently had a similar problem, and it took me quite a while to actually solve it.
Yeah, that's the million-dollar question, I would say. I don't have a good answer for it. In a healthy community, which I believe the driver that I maintain has, and it's an open source project, so it doesn't apply to closed source projects or corporate projects that have smaller communities or contributors there. But in this case, helping the community with pointers, how to reproduce it, how to create a scenario to reproduce it, where to go, in what direction to go to test it, would greatly increase the chance. But to be honest, it's very hard. It's very hard. And it's really annoying to me as a person, because I've seen countless times where people would come to, like they see an exception that's very specific, and they see it once a week in their log files. And it's like, I know it's a problem, I see it there, but I can't wait for a week with the debugger attached just to get to this endpoint. And there is no easy answer. Of course, the typical things that you would do with debugging. You would put tracing, you would put some sort of telemetry if that's required, like if it's depending on the issue. You would try to see signs of the state of the system at that particular moment. Was it running out of memory? Was it running out of space? Are there related issues? By the way, we often neglect to look at like in this specific case that I explained, the driver was running out of memory, and that caused the problem, but the problem was like 2 minutes or sometime after the out of memory error. So you would get at some point an exception that says, I can't map this data to this request, which indicates that there's a problem in the order, but you would get it much after the out of memory. And in this case, you just had to scroll back up several seconds or minutes to see that there was something happening before that. Again, hard question with many answers. Something else? I can also talk about mountain biking and occasionally running. I'm a very slow runner, so I can talk about this a lot, slowly. Well, there was promise of beer, so I think we can close. Thank you very much.
So, closing to the end of the talk, if you plan to have some questions, we'll have a guide to give the mic to the audience.
Oh, okay.
I think we can start. Okay, so we can continue with the next session. It's a great pleasure to welcome Ken on stage. So for those of you who don't know who Ken is, he's a Java pioneer very knowledgeable, and he'll talk about something very interesting for many of us, and also something that's I think also for me, is how to teach properly Java and what you can do about it. So can you have the word?
There we go. Thank you all for coming. I'm curious how many of you currently are teaching Java, evening courses, full-time at your company? Okay, well that's cool. What we're going to talk about today is, you know, as someone who's taught Java since probably 1999, and as it's evolved over the years, I had the good fortune of working in a school where we could evolve with the language, which sadly isn't always the case. And even after I've left, I've retired 4 years from the classroom, there's still new ways to deal with Java. Ooh, let me get my nice control. So, when I was at Dawson College in Montreal, and Dawson College treated computer science as a career. So for instance, in the same school, you would go to be a nurse. You'd go to be a manager for businesses. And we treated computer science as a practical topic. In 3 years, we made our students job ready. I think the term in most of the world is called an associate degree as opposed to a full undergraduate degree. And my specialty back then was the final year. I taught the major Java project courses. We would build an Outlook clone in pure Java, and then we'd build a complete e-commerce system, 100% Java, even the front end. But that's for another story. I also teach at a local university where I started teaching C, C++, and eventually Java, primarily to students with little or no experience. So, what we're going to look at is items that deal with, that's available now in Java 23 and 24. I'm hoping for 25 they'll be finalized, but when you consider that the vector library is in the 8th preview, I'm not quite sure when they're finally going to solidify these changes. So a lot of the things you'll see here, you've got to use enable preview to make them happen. So first of all, let's begin with something simple. What is programming? Well, there's a few definitions, but when I'm teaching and what I've realized is the first thing students need to know is abstract data. You need to be able to model the problem. And that's difficult because students, they've taken your course because they want to write code, right? Maybe they've done it as a kid, they've got a Raspberry Pi, and code, 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 that's all that's exciting to them. And you've got to get across to them, wait a minute, here's a problem, well, what are you going to do? So for instance, I would use these as examples. My favorite, of course, is the one on the left, because that's the book I wrote. But I would give these to my students and I would say, okay, model this, right? Forget, we're not talking loops or anything. Just tell me, what's the title of the book? What would you consider that to be? The number of pages, the ISBN number, and so on. And these would be the first problems I would give to a student before we write any code whatsoever. And as this is about the changes in the language, there's the traditional chart of primitive data types, right? I would have this slide up and I would lecture and, they would look at this list and go, huh? And then I realized there's just too much there. So I needed to shorten it a bit. And so these are the data types that I believe a beginner needs to know. And maybe the last one is iffy, but really, string, although we always use that as the last one, that's not really a primitive, it's probably the most important one to your students, because that means they can type anything in on a prompt. Int, long, short, really? Short to me is an advanced topic. Has anybody here ever actually used short? There's 3 or 4 of you. We'll talk about that later. Double, obviously. Again, float. Float is nice. Float shows up in Java graphics. But really, you got enough problems with the precision of double, you're not going to make it worse with float. Boolean, well, everybody wants true and false. But the new one I've added there is the local date time. Of course, you all know that you're forbidden from using the date class ever again, right? Why they won't kill it, I don't know. But if you're going to involve dealing with dates and that information, you want local date time. So with that information, I can take, for instance, the entry for my book, and this is how I teach my students how to aggregate data. No more Java beans. They'll come up. They're not terrible. There's still libraries that require all those sets and gets. But the reality is, and it's a word I don't like to use because it scares students, it's immutable, right? I save that for later on, right? And then all they think about is the X-Men and stuff like that. And, you know, I have to bring them back to what we're really doing. But this is how I would present it. Students would frequently look at the ISBN numbers, right? It's all numbers. Why isn't that an int or a long? Well, what I remind my students is, if you're not calculating with a numeric value, store it as a string. Because if you store it as a numeric, somebody on the team is going to decide, let's divide the ISBN by 2. You can't do that. So this is where I start now, right? Again, I've left the main in there. We'll understand why in a few moments, but it prevents errors from showing up. But records are the key today, right? Start records early in your presentations. So let's continue on. What is programming? Well, it's step-by-step problem solving. This is when we want to start writing code. Here is where my biggest struggle with students comes in that that's what they want to do. Here's a problem. I don't want to think about it. Quick, give me the keyboard. I'm going to write code. I need to encourage my students to actually write. Write me a page. Tell me what you plan to do, right? I don't care about the code yet. I want to know if you understand the problem, if you can tell me the steps. Now, some teachers may do this in the form of flowcharts. They're okay, but I really think if you get people to write things out in their natural language, French, English, Bulgarian, whatever, they think about what they're doing more thoroughly rather than just jumping to code. Here's a slide that I used years ago, and there were other slides, but I always like this one because this is the program that started my career as a software developer. In 1980, I bought myself an Apple II Plus. And I know I'm old because when I mention that to some of you here, you all go, what's that? Right? Look it up. I didn't put a picture of it here. But I brought this thing home and I became obsessed with it. And in the 1980s, there were dozens of magazines dealing with computer programming. There were bookstores just about computer programming. I was working as a photographer at the time. But every night I come home from work and I would just type in every program I could find. And this was one of the first, and it's a silly thing, right? It's the classic guess a number from 1 to 10. It has, of course, the evil go-to in there. But really, it kind of works. And this was just so easy. I could do something interesting. But we evolved. I called that spaghetti code because you wrote as you thought. I need input, I need to evaluate it, I'm going to show the answer. It's actually not a bad structure to begin with. But then as we move on, yes, we talk about structured coding, object-oriented programming, though I have to admit I usually describe it as confusion-oriented programming. I really thought I was loud enough. I always get told I'm too loud. So object-oriented programming is confusion-oriented programming. Because when you're trying to explain to students classes and what you need and when you need a class, they're just scratching their head and going, I just want to write code. I don't want to organize it. Structured I can get across, but I'm still having trouble having them understand that. So do we really care when we're starting to teach somebody what the methodology is? Well, as I said, not at first, right? You want them to understand the problem. You want them to write it up. So whether it's spaghetti, right? You want to learn assembly language, or you found a basic interpreter somewhere, or structured or OOP, they're organizational decisions. They become part of what you will eventually do, but you don't want your students to get hung up on, ooh, it has to be OOP or structured or whatever. You'll find that it can come naturally. And of course, you can write really good code and you can write really bad code with either of these, any of these three methodologies. So why are we all interested in Java, right? In my career, I have programmed, well, BASIC, though I didn't make much money in that. I actually programmed in PL1. Does anybody here know what PL1 is? I thought so. It stands for Programming Language 1. It was invented by IBM for mainframes, and I used a version for the IBM PC in 1984. And I made a lot of money writing it. But it was a structured language. When you look at C, and you look at many other structured languages that came out of that period, they're all related to PL1. But that was a specific project, and from there, I started writing professionally in C, in Pascal, and these were structured. It meant that you have to consider what are the tasks that you're doing. And then we got to Java, and I got excited about Java because for the first time you had standard libraries for exciting things you needed to do. But the only thing I could ever do in C or C++ was scanf and printf, right? And then try and figure out what other library. I want to do a GUI, oh geez, forget that, right? There's no standards there. And suddenly Java had all these amazing standards. So we liked it because it was more object-oriented than C++. Would you really let your children learn C++? I certainly wouldn't let mine. That massive set of standard libraries that I mentioned. The numerous tooling options. You know, back in the day, if you were doing C, C++, well, if you were someone who hated themselves, you used VI. Or you got a Windows machine and you used Microsoft C. I worked for a number of years writing C software for Linux that I used to write under Windows and then copy it to the Linux box because I didn't like the editors in Linux. But that was just me being strange. Write once, run anywhere. The classic cliche, but it is exciting. It means that you don't care what computer you're on. In my program at Dawson, we transformed ourselves from a COBOL school to a Java school. And in making that decision, C# was the other contender, but we realized if we had C#, we were going to have to force Windows on everyone. Now, quite frankly, I'm a Windows fanboy, so it wouldn't have bothered me. But I knew our students had Macs. I think in my 31 years, I only ever had one student who admitted to having Linux on their home computer. Right? That I thought was interesting. I thought more of them would. But now, you're no longer thinking about the machine. You're only concerned with the JVM. And of course, all the different platforms it, well, used to run on. I remember my first cell phone actually had Java, so I could play Snake on it. That was exciting for 3 or 4 minutes. But then things happened to the world of Java. It suddenly became unfriendly, less popular. First of all, I was looking at the latest download from Adoptium, and it's 354 megabytes. Now, high-speed internet and everything else, but you look at students today and, you know, they don't have a sense of going to a special website. They go to the store, right? Let me download from the store. Java has evolved amazingly over the years, but what I've perceived is the evolution has been to service the senior developer, advanced systems. I'll show you a brief example of streams, and you know, streams are really exciting. And then I read the article where somebody actually used the JMH to measure the performance of strings. They're about 100 times slower than a loop. But they're cool, right? They're professional. And then there's that lambda word. The excessive boilerplate. And then, of course, there are the terminology that we're all supposed to know. Orientation. Wait a minute, I thought there was a problem with that in the US. I'm sorry. Polymorphism, inheritance, mutable, immutable. And then the last one, I just mentioned it, stream. Why does it care how I pee, right? What's my stream? No, 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 right? It's just not fun anymore. So let's take a look at what has changed that I believe can bring some of the fun back to Java. So here we go. Here's the classic first program that every book has. As a Canadian, of course, I won't say hello world. I'll say hello moose, right? And I remember standing in front of students in their first class and saying, okay, let's take a look at what's in these 1, 2, 3, 4, 5 lines. There's this public thing. Then there's class. I'm not going to tell you about that. Hello, or opening brace. What the heck's that? More public, static. Do I have to use a fabric softener when I'm coding here? I don't know. Void again, main, string, square brackets, args. Oh, another one of those bracey things. System, and then out, and then print line, and then finally the string thing, a semicolon. I mean, it's endless. In those few lines of code, all the stuff that's there that I have to tell my students, just ignore that, right? Look at the print line. Isn't that nice? Look, you've written your first program. What? So public class, that has to do with that class thingy, right? That you're telling your students to deal with. Access control, that sounds ominous. You know, what type of object? Wait a minute, there's more than one, right? There's a class, there's an interface, there's a record. I've probably left out some. There's probably somebody inventing one right now. And so I would find myself in a classroom telling the students, just ignore that. We'll get to it. Eventually you'll learn what that's about. Or how about in the code? 6 pieces of information to print the word hello moose. Access control again. Object or no object. That's static. Return types. Method names. Parameter types, it just goes on, and parameter name. And again, I say ignore all of that, right? You can copy it, it'll run, you'll be happy. Eventually, we'll get to that. But I knew it bothered them. What was I hiding from them? What was I keeping from them such that I wouldn't tell them what this was about? And then in September 2022, Brian Getz, you should probably all know his name. He's one of the chief developers of the Java language. Someone who has told me off numerous times, but that's okay. He wrote this amazing design note calling for an overhaul called Project Amber. for the first time, a serious look at simplifying the language. And that simplification comes from the fact that if you always have to write system.out.println, why the hell do you have to keep writing system.out? It finally got through. So, a main method that makes sense. JEP 495, simple source files and instance main methods, still in preview, but let's take a look at the signature for main. It's just void main. And this is not just, you know, if you're doing a Project Amber project, this is now allowed in any Java application. You still got to do enable preview, but you can take your classic Java application that doesn't have any parameters at the command line, and you can get rid of that public static void blah, 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 and just put in void main. The JVM has finally figured out all that other crap that you always had to write. You don't have to write it anymore. Hooray! And then how about the message? Finally, system.out is gone. It's over. It's the end. And again, can be used in regular Java. There's even, my favorite is read and read line, where you can include the prompt in the request. We'll see that in a moment. Fireworks, I'm excited. And now for something completely different. Say hello to the classless class. There you go. There is a complete, and I'm sure you've all seen this, there is a complete Java program. You can run it from the command line. If your IDE has an enable preview, it'll run in that as well. No imports, no decorations. Now, we know what it really is. It still is public static void. There's still a system.out.println sneaking into the bytecode. That hasn't disappeared, but finally a recognition that we don't have to keep writing this. We don't have to have our students write things that don't make sense to us. The next thing, next change, if we take this classless, is what's called the tolerant launch protocol. So we all, if you've ever done command line, you know you normally say Java C first.java, and then you say Java first, and it executes. Heaven forbid there's more than one class, because then you got to say Java C for each one of them. There was a quick change that allowed you to say Java, the name of the source file, it would compile and run. That's actually been around for a few revisions. But the big change is if first.java has an import for another Java file in the same package, or actually the package would be there, it'll compile those as well. It's kind of a mini build system for the first time. At this point, we've talked about data, we've seen the simplified, they've all done hello world. We can start talking about the good stuff. Sequence logic, sequential flow, selection logic, conditional flow. We're going to see some of those soon. Iteration logic, count control. Those are the classic terms that you see in every textbook. So how do you teach logic and syntax? Well, in my belief, it's examples. Try and stand in front of a student and give an in-depth presentation on a for loop. Right? Half will go to sleep and the other half will be checking their phone. You gotta make them start writing code, and code you're giving them. Give them examples. And then get them to change the examples. Make it their own. And make sure that all your examples are available to them. So, we want our students to write their first program, the program that's going to get them a job. Here we go. You want to get a job at the Canadian Space Agency? There you go. Your complete program. All that decoration stuff is gone. It's just the logic, right? There's a for loop, a nice print line, blast off, and to run it, well, now I've got to add that enable preview. I'm hoping to see that go away shortly. Remember this game from earlier, my spaghetti version? There it is again. So I decided, or I used to show this in what I would call pure object-oriented Java. I've actually shortened it a bit. So there it is, 27 lines of code to play this game. I have a longer version where I put the secret number and the guess number in a Java bean. Then I could get it up to like 35 lines of code. And it's like, really? Heck, I'm even a purist. Let's see, does the laser work on this thing? There it is. We can't see it. I even do a system.exit. I don't much anymore, but there are reasons for it. Another presentation. So, of course, people come back to me and say, oh, hey, we don't like Java because Python is so much easier. I actually asked an AI to write this for me. I do a little Python, but not enough. And so this is what came out, and it's perfectly good code. There's nothing wrong with it. I still don't understand what happened to the SE in there, but every time I read that, I read elf, not elif. But I'll have to deal with it. So people will say, look, 10 lines. You just did it in 27 in Java. Well, here it is in 10 lines in Java. It's actually fewer lines because we have those braces at the beginning and the end. It's the same idea. It's the same program. It's not perfect. That integer.parseInt bothers me. I don't quite understand in Python by casting. It converts it into an integer, but we're getting there, right? I'll needle Brian some more. But there you go. This idea that Java is complex, is difficult, that's ancient history. So what's going on here? There are two imports that you don't see in classless Java. And they are the import module java.base. How many of you have seen this? Oh, wow. You don't know what you're missing. Imagine that you could have an import that would bring in the 20 or so most significant Java libraries, collections, streams, file I/O, all the good stuff. And you just need one import. The static io.io, that's what gives us the print line, the print, the read line, and the read. So let me talk about some other ideas about teaching Java to students today. I'm going to talk about the switch. I'm going to complain about the switch. I'm going to complain about if. I'm going to complain about imports. So the first thing is you have to stop teaching and using, I'm exaggerating here, but I still consider it the 17th century switch. Right? Java switch is identical to the C switch. I know why it's written that way. It has to do with the machine language of the CPU and the way it handles comparisons. But really, we've all seen this kind of code. Break, 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 break. You know, they tell us how goto is evil. We should never use goto. And so what does Java have? You know, Java has two goto commands, break and continue. They're absolute gotos. wait a minute, they said they were bad. There's no need for this anymore. There it is in the 21st century. Now, the switch now comes in expression or statement. The difference is statement doesn't return a value, so instead of putting a value there, you could call methods, put in braces, do everything you used to do in a switch. And this is my favorite, is the expression where it returns a value. Right? If I go back for a moment, I don't have to keep repeating. What's the principle? DRY, don't repeat yourself. The switch is all about repeating yourself. And now it's gone. It's over. And I can certainly explain that to a student far easier than I can explain the first case and the need for the break. And of course, students are going to forget the break. And then they're going to get results they don't expect. And then they're going to put up their hand. And I'm going to have to run over there and go, you forgot the break. No, you don't have to anymore. Or how about this one? To me, we're going to see the most exciting advance in the switch. I'll make a strange remark. I used to program in Visual Basic 6. I made a few bucks. VBA is still based on that. And it had a select case that was brilliant. We'll see it in a moment. So here we go. I want to check a range of numbers. So it's the old if, else, if, else, if, else, if, else, and on and on and on. And then we can print the answer at the end. Again, why? If anything, this should be a switch, shouldn't it? But of course, switches only test for equality. Are you equal to it? Well, not anymore. So we're going to see two new versions. The first version that came out, I think around 22 or 23, was the pattern matching switch. In this case, and this is an example of halfway there, by the way, but it's an interesting value. I can switch on an object, not an integer, and my case simply looks to see if case integer, that is an integer. But you can imagine it could be anything. Once it's made a match, we come to the when clause. And the when clause allows me to do what Visual Basic 6 allowed me to do forever. Do any kind of test I want. I'm not just restricted to equality. Here I'm doing if I is greater than or equal to 100 or I is less than 200. Now this is an integer, so it handles the conversion automatically. But if this were an ordinary class, I could be calling methods. As long as the method returns a value, then I can use it in my test. So I can use this with Java Beans if I want to, with records, whatever works. And I print it out. But of course, when everybody saw that, they went, but what about primitives? And now we have the primitive switch. So now I can say int I don't have to wrap it in an object to make this magic work. And when it fails in a when clause, it just goes to the next case. Didn't mention that before, but that's how it's working. So the when is actually the determinant of have we made a match yet, as opposed to the type. So the pattern matching says, we can pattern match on an int. Well, we can pattern match now on floats and doubles. A little scary. Make sure you're doing between ranges and not absolute values there. But all that is possible to us. And again, this is something, well, to me it still makes more sense than if, else, if, else, if, else, if, or the old switch where I couldn't even do this anyways. Ooh. I dropped that out because you can't have a presentation unless you see real code. So let's look at some real code. So I was doing a presentation on Java best practices. I presented it to a Java user group in Riyadh, Saudi Arabia, online. I told them I'd come if they paid, and they smiled and said no. But in writing this, the purpose of this was to demonstrate the difference between using a loop to read a file as compared to using a stream. And as you can see, the stream is smaller, and there's other things, but that's not the point I want to make. The point I want to make is what I needed to write up top there. I needed to import the buffered reader, the file reader, the I/O exception. Oh, I want to use the logger, so I got to get the logger and the logger level, and oh, NIO files, NIO path, util stream Java. You want to know why your students drop your course and go take Python? That's probably one of the main reasons. And it's all great that the IDE will tell you that this is happening. Cool, but that doesn't make it any easier to understand. Whoops. Wake up, computer. So, let's look at the newer version. So here's the exact same code. I've jumped right to classless Java. So I do have one import, but notice just one. The Java logging module. This takes care of system logging and takes care of levels. All the others, the buffered reader isn't necessary because the default import is java.base. And so they're all there. And so now I can talk about the code. So I have this computer that if I walk away from it, it has a tendency to save battery power, even though it's plugged in. So I will stand here now. I won't leave it. I think PowerPoint keeps it from happening, but not my IDE. But again, you can see, you know, if I'm standing in front of a class, I'm talking about how I'm reading lines from a file. I'm not having to explain all those imports. Oops. Come on. So that's where this came in. Now, on the left is what I needed. Now, on the right, so let's imagine that I still want to write this in classical Java, right? That I still want to, you know, have public class. What imports do I need? Well, then I need to be explicit in the imports. The trigger for the you know, implied imports is when you just write void main and write your code. Then you don't need Java base or Java I/O. But if I were doing this in a standard Java program, I just need those three. And if I'm not a very good teacher and don't teach logging, I can get away with only two and have everybody write system.out. Oh, no print lines for checking. But again, look at the simplicity here that we didn't have before. So, some other points. Get your students to use a logger early. Right? It's really easy. I'm sure all of you write a logger and put into, shouldn't go dark in here, you know, you write name of the class, dot get name. Well, I did that forever, and then for the first time I asked myself, why am I doing that? If I look at the Java docs for get logger, it just wants a string. So just write a string. If I've got to copy the name of the class so that I'll get the name, why don't I just copy the name of the class and put it inside of quotation marks so it doesn't have to generate the logger from it? And then there I go, level info and so on. Now again, we're using the system logger. I haven't played with this with SLF for J or, you know, the other loggers. But when we're starting off, it's important to me, at least, that my students understand the difference between user interface and developer information. They're two different things. The logger makes it clear that the output is information of significance to the developer and not to the person who might be using the application. At this point in my course, now I can start getting theoretical. So when we talk about methods, we all know the solid principles. I have two that I'm most fond of. The first is single responsibility. When a student gives me code, I will actually look at every single method and count all the things it does. Now, I make it clear the goal is one. It's never possible. And sometimes it becomes excessive when it is. Many years ago, I taught C to a company that wrote software for satellites. And they wrote it in Fortran, and every method in Fortran was a separate file. The application was tens of thousands of files long. I was like, oh my, ooh, ooh, ooh. But that ensured for them the single responsibility principle. So look at your code. How many unique tasks is it doing? Now you've got to talk about classes. Here's where separation of concern comes in. This has to be on their mind. I'm writing a class that's part of the user interface. I'm writing a class that's a business process. To use from Ghostbusters, I'm avoiding crossing the streams. I'm keeping it independent. Whoops. Oh yes, here we go. I hadn't realized it was there. Then, of course, there's the most widely used pattern in software development. It's the stream of consciousness pattern, where you just write things as you think about them. Right? Going back to when I said my students have to write a paper on what they're going to code, so that I can identify that they're doing this and they haven't organized it in any way. So stream of consciousness. Thankfully, people don't write books about it, but people still do it. We're just about the end here. Unit testing. I'm visiting the chairperson of a computer science program at a university in Montreal. I won't mention that it's Concordia. And as we're talking to the chairperson, and that's somebody I've known over the years, the first thing we asked them, so this was 2 years ago, we said, what version of Java do you have in your program? And they're a Java university, in that's their primary language. And he proudly told me they were using Java 8. And he continued to say, there'll never be a need for anything else. Okay, Java 8 was significant, but other things have happened. But okay, we can deal with that. And then I asked them the question that blew me away. I said, when do you teach unit testing? Right? We taught it at Dawson in the second year of a 3-year program. This unnamed university proudly told me that it is offered in one master's program, and they have 6 of them in computer science, but only one of them, software engineering, gets 1 course in unit testing. They don't see it at the undergraduate level, and 5 out of 6 computer options like application development or web development, they never get shown unit testing. Really, unit testing, if it's not your first course, it can't be any later than the second course, right? I would have my students, when they would submit work to me, they had to submit the unit tests. And the first thing I would do is run the test suite. And if I didn't like the results, I'd send it back. I'm not even going to look at your code, right? I need better test coverage. I need a better range. You can't just test for things that work. You have to test for things that won't work. And only when the unit tests are sufficient, based on their level, obviously if it's a first level course, it's not going to be quite as extensive, only then will I look at their code and comment on it. I should point out that when I return code like that, there's no loss of marks or anything, right? I don't want to depress them. I have other ways of doing that. I want them to become successful. So, do unit testing early. And then there's the question of build systems. Again, maybe not a first one, but eventually you're going to want to use things that aren't in java.base, aren't in the JVM. And regardless of the IDE you use, trying to figure out how to add libraries to the class path or where to stick them in IntelliJ or NetBeans or Eclipse or whatever, there's a whole course in that. I'm a fan of Maven, and Maven can be quite simple. You don't have to get into all the profiles and the build plugins and everything. Default is fine. But for instance, I don't teach Swing anymore. It's archaic. I like JavaFX. That's when I typically bring Maven into the mix. Few lines of Maven code, and they're all set to go. And again, unit testing. So, some final thoughts here. Use an IDE early. Maybe not on day one. You don't want to overwhelm them. But by the end of that first introduction to Java, they should be using an IDE. There's no denying how useful it is. Things are getting more exciting about AI, but I get to talk about that tomorrow at the end of the day. Comments. I once contributed to a project. I'm telling stories. And I was giving a sample of some code for the example section. And as a teacher, the best way to describe what I do is I comment excessively. So I submit this code because it's meant to be an example. It's not part of the open source project directly. It's an example of how you'd use it. And I submit it to the group, and they send it back to me saying, we can't accept this. And I go, why not? They said, well, we don't mind the fact that you put comments in the Java code, but we still think you put too many. But you put comments in an HTML file. That's just not done. And I went, what? And even worse, I put comments in a POM file. Well, this was grounds for them to revoke my programmer's license. I had to remove all the comments before they would accept it in the project. I never submitted again to them, and that code is long gone from that project. But I could not believe the hatred for comments. It's all nice to say we should write code that is self-documenting, right? I sometimes say, you should be able to stand out on a street corner and read code out loud, and anybody walking by should know what you're doing. Well, that's not going to happen. And because of that, you need to comment. I say use the Java docs style. You don't have, I had one teacher once in my program who taught their students to comment every single line of code. Those students hated this woman. She was a brilliant programmer, but it was ridiculous. At the very least, you comment every method, every class. And I don't care about access control, right? Java docs, the tool, will only pick up the public methods, but I still require my students to comment every method in that style. Private, protected, the whole family there. And then finally, my last thought for today, and I'm just about out of time, is have fun teaching. When I was a young man, I wanted to be a singer, and then I discovered I can't sing. Then I wanted to be an actor, and I discovered I couldn't act. And then I wanted to be a dancer, and actually that was iffy there. It could have been a direction I went, but I was smart enough to realize I couldn't. And as I went through a number of careers, when I finally got into the classroom, I finally got that performance fix. And that's why I love to come here, right? I have fun. And if you have fun in front of your students, they're going to sense that, and they're going to enjoy what they're doing. So, thank you all for coming. I'm around if you have any questions or anything, and have a great rest of the conference. I don't have an opinion in terms of forward here, right? It's a language on the JVM, which means it can be available in a range of platforms, and that's what's in I can't help but feel that you still need to learn Java first, and then evolve the complement in any other language coming out.
О, аз на друго... Да, аз на гура нещата не бутам. Тайното имам срам. Тайното имам срам. Не, тук не съм. Имаме един час.
No, da ги...
Well, definitely, of course, I have a similar presentation with Java best practice, and that's where I focus on explaining to people, variables are nouns, classes are nouns, methods are verbs. So confusing to read code. The name of the method is wrong. At least write get wrong. So definitely, yes, you need to teach that along.
So you mentioned that school teach your kids would it be Java?
Well, I would have said, up until 2 or 4 years ago, probably. Because just they were code and work. Guess what? Java would have said, wait, I've learned something Python. I still know that Python and make Python. And now I can have the same number of lines in Java. And get the same result. So, I would, yeah, I would definitely support it on each case Java. Now, the other issue still to be resolved is online systems. So what I mean by that is we know that we have Jupyter notebooks or so on for Python. And for many schools, there's no longer any budget for technical support. You can install Java on a lab of 30 machines. All you can do is go to the browser. And that's the problem. But we're starting to see some really interesting projects. Everybody but Oracle. So Oracle has one that's based on JShell. Well, JShell is live in the wild. But there's one called, I think it's J. There's a number of systems, and what they've done is bizarre. They've created a JVM out of so that, I can sit there in my browser and write Java code and methods and all of that, and I can run it, and it will come out on my browser. Now, we're probably 10 years too late for this. That's the problem. It should have been there 10 years ago. But again, the emphasis was on professional things. We have lost that market, but people are starting to recognize it. And it comes down to, why are you learning programming? You're learning it because it's interesting. Really excited about programming? You should be learning Java.
There was also a little title about switch Java, let's say. There was like from 100 to 399, but should there be 199 or something?
Oh yeah, I'll check that. I always find some of the thank you for pointing that out. Yeah. My pleasure. I'm glad you enjoyed it.
Yeah.
I teach labs in Sofia University, and I can't get my professor to use Maven.
So if he doesn't use Maven, is he doing it strictly from the command line, or is he using IntelliJ?
Yeah.
So here's the key. It's why. You know, yes, those NetBeans are used. I don't. The issue is, can I take the code I develop in IDE A and run it in IDE B? And there lies the problem. Right? Eclipse has their own build system. IntelliJ has a very sophisticated build system. You know, I've had students submit code in IntelliJ, and I'm not fond of it, so I've got to spend 20 minutes picking it apart and putting it into a standard format. You know, NetBeans, their primary build system was AMP. Now it's Maven. That's the key. You know, is in the course outline, does it say students may only use IntelliJ? If he can enforce it, then there's nothing you can do. But if you've got students who, you know, their friend told them Eclipse was better, NetBeans, or whatever else is out there, and it means in my classes, that's what I would tell my students. I don't care what you use. As long as it's Maven based, I'll be able to open it. And so I've had many students who use IntelliJ in school, or student get almost, and then I can open it fine because it's delivered. It's standard to Maven. Try that.
Yeah, so my question was around JavaFX.
Okay.
Because at first we start with plain Java project, which isn't, you know, a big deal, it's great from IntelliJ. But when you go into JavaFX in the second week, then it turns into Maven. It's a big shift. And also it automatically creates a module which defines the Java module. And we introduce this subject at the 90. So it's a big
there's no, you know, there's no easy thing there. You know, I have, I actually have a JavaFX project that's Maven based. But I wanted to redo it. So, for instance, Palm Farm. So this is what I mean by excessive comment. Put my comments in the bottom so that my students know what each of those are. Like I even have things that we don't use, just so they know. But I have my properties, my dependency. Apparently I'm the last person in the world who still uses default goals. And then I need two. The reason I need two is because of the enable. And that's it. Down here. No idea what that's there. So that's all it is. And then the source code. This is just a little program that opens in a box and gives you a box. That's all it does. Get files. This is now unique to NetBeans. Oh, that's the source code. Yeah. So this is, you know, this week's first. The thing about the module info is, you know, that it already exists in a default situation. And module info is also invaluable if we wanted to distribute an application with the JRE. So it's now actually very easy to create an application using Maven that brings in the JRE as a module. And now you can just give somebody the jar, the exe, and they don't need to install Java. Something specific to IntelliJ that's adding that, which means that now you're confronting something I always hated, telling a student, ignore it. I'll tell you that in like 9 weeks. And it's like, What are they hiding from me?
That's not just fun. So when professor worked around the whole thing, we are creating a Java project from a previous Java project. So we need to do the whole set of which 20 presentations like. It's very big.
Neat. Well, have you enjoyed it? You've got a few ideas. Absolutely. So, in the order we had at Dawson, we would have to give a course how many hours of lecture, how many hours of lab in the school, how many homework. Typically, we would expect from our students, because we had lab, we had a 3-hour lab that I was so we expect them to have a minimum of 3 more hours a week. Because we also recognize 85 or 6 years to go. So you can't say, oh, you got to spend 10 hours a week on my notes. I do have a life. Boogie. So we generally do our best to put a lot of emphasis on in the lab as much as we can there. And then expect another 3 hours.
Look, that's not
Each of the courses, 5 courses, so that's 20+ hours a week. Those courses are using universities. The professor gives you a course as if these are the only courses. They just pile stuff on the students. Normally we would have a lecture would be 3 hours a week. Labs would be 5 hours. And then, so it would be 3, 5, and then 3. It's my pleasure.
И дали там минути трябва да го правят също по някакъв начин. Що е така камерата? Много интересно.
to me the best when it ended. Even tried to bite my tongue when you started. Now you're texting all my friends, asking questions. They never even liked you in the first place. Dated a girl that I hate for the attention. She only made it 2 days, what a connection. It's like you'd do anything for my affection. You're going all about it in the worst ways. I was into you, but I'm over it now. And I was trying to be nice, but nothing's getting through, so let me spell it out. A, B, C, D, E, F, you, and your mom, and your sister, and your job, and your phone, fast car, and the church you call art. Fuck you, and your friends that I'll never see again. Everybody but your dog, you can all fuck up. You said you just needed space, and so I gave it. When I had nothing to say, you couldn't take it. Told everyone I'm a bitch, so I became it. Always had to put yourself above me. I was into you, but I'm over it now. And I was trying to be nice, but nothing's getting through, so let me spell it out. A, B, C, D, E, F, you, and your mom, and your sister, and your job, and your friends, kiss the couch, and the way your voice sounds. Fuck you, and your friends that I'll never see again. Everybody but your dog, you can all fuck up.
Me not working hard, yeah right, picture that with a Kodak. Or better yet, go to Times Square, take a picture of me with a Kodak. Turn my life from negative to positive, I just want y'all to know that. And tonight, let's enjoy life. Tonight, I'ma love you tonight. Give me everything tonight. For all we know, we might not get tomorrow. Let's do it tonight.
Don't care what they say, all the games they play. Nothing is enough till they handle up. I want you tonight, I want you to stay, I want you tonight.
Grab somebody sexy, tell them hey. Give me everything tonight. Give me everything tonight. Give me everything tonight. Give me everything tonight. I might drink a little more than I should tonight. And I might take you home with me if I could tonight. Baby, I'ma make you feel so good tonight. 'Cause you might not get tomorrow. Tonight, I'ma love you tonight. Give me everything tonight. For all we know, we might not get tomorrow. Let's do it tonight.
Don't care what they say, all the games they play. Nothing is enough till they handle up. I want you tonight, I want you to stay, I want you tonight.
Grab somebody sexy, tell them hey. Give me everything tonight.
Не, няма да се. Просто ушите ни заминават, човек. Няма да стане.
can wait for after lunch break for
Yeah, that's normal. People are coming slow. Yeah.
1-2 minutes.
Yeah, for sure. Then we see people start coming in. Then
Yeah.
How is the conference so
So
far?
everything perfect.
Yeah,
And
it's
when people are interested in the
good impression. I mean, it's
You-
beginner friendly, so
not to make a mistake, you've been a contributor to Spring Cloud AWS.
I'm maintainer.
Are you a maintainer?
Yeah.
Wow, nice. Nice. Most people already are in, so
you see some people walking. I don't know, however you want.
last 20 seconds, not to waste time from the session.
Okay.
After lunch, it's a bit tough.
It's a very limited time as well.
Okay. All right, so I hope everyone had a good lunch, and now we are ready to continue with the next session. It's a great pleasure to welcome Matej Nedic on stage. He's in fact the main maintainer of the Spring Cloud AWS project, but he's not limited only to that. He's been a contributor to other projects in the Spring ecosystem, like Spring Cloud Config, Spring Data DynamoDB, and others. So, Matej, you have the word.
Thank you. First of all, I would like to thank everyone for coming. Today, we will be exploring how to build Spring applications on AWS. We will be doing this in friendly way. So before I start, who is actually developing on AWS? Who is hosting? Can you please raise the hand? Okay, perfect. So because of this, let's start with first what is AWS. This is not an easy task to explain. So let's go with what we are doing every day on work. We are building some kind of services, right? Some of us might be using databases to store the data. Some might be using caching to have faster response time, maybe to save data as well. Maybe some kind of messaging queues to decouple our services to make some kind of back pressure as well built into it immediately. Or some kind of huge file systems to store files. Maybe you're working for government, you have some signed contracts and so on. Since all of this needs to be hosted somewhere, provisioned, meaning that we would have to have on-premise farms, right? And we would have to host these services, update them, think about, for example, if we are using databases, about read replication, and so on. This is not an easy task. So instead, we can give money to AWS to do this for us. You can host it on AWS RDS. AWS will take care of high availability, about replication, about everything. You only need to know which endpoint to call, basically. Second elephant in the room is Spring. And this is really old framework. It's my favorite Java framework, to be honest. And some of us that are older or have had the pleasure to work, before you had to configure all of your configuration in XML bins. Today, things be evolved, right? And with Spring Boot, you are basically not doing any more of configuration. You're just writing some kind of property files, and everything is configured out of the box. Meaning, if you would use database, you would use Spring Data JPA or JDBC, you would have your data source being already auto-configured, everything would work out of the box. If you use, for example, caching, and you might to use Redis, right? You would have Spring Data Redis. On AWS, you can provision Redis as well. They will take care of everything. But because there are unlimited use cases in life, this means that there are unlimited almost services on AWS. I don't think that one person can name them all. And some services can be only found on AWS. They're proprietary. Because Spring does not have integration, Spring Cloud AWS project was born. Before we continue, I need to give shout out to my colleagues. This project is really old. It predates Spring Boot itself, meaning some people on the roster have changed. Today, it looks something like similar to Tomas Fernandez, Maciej Valkowiak, and myself. A little bit about me. My name is Matej Nedic. I'm the lead Java engineer at Infinum, which is Croatian agency. I have been core team member or maintainer, one of the maintainers for Spring Cloud AWS for up to 3 years now. I have contributed to Dapper SDK, Spring Cloud Config. I have contributed to Spring Data project, and so on. Lately, I'm working with Kotlin, Spring, and I'm mostly designing solution on AWS. I really like to tell everything through a storyline. I think it's easiest to get it. So in COVID, we really did a lot of online purchases. Web shops were blooming, for example, Amazon and so on. Now imagine we have some kind of payment service, right? And invoice service. Payment service would process the payment. Once it's processed payment, says, okay, I have done everything, it will call invoice service via HTTP. And this is fine. On AWS, it would look something like this. Payment service, you have something called API gateway. This API gateway, you would expose your APIs, you would do authentication, authorization, and most important, rate limiting. You would have payment service calling API gateway. Your request will be authenticated, authorized, and it would be forwarded to the invoice service. Afterward, invoice service will start generating PDF, whatever it needs. But we have one kind of problem here. What if API gateway invoice service is down? Well, then we need to have something called circuit breaker. We don't want to really spend CPU time and memory time because this means costs. So we don't want to really send the request to invoice service if we know something is down or not working. But now thinking, does payment service really need to know if invoice service has issued the invoice? Well, it really does not, right? It does not care if invoice service is up or not. It does not actually care what will happen with the invoice. And this leads us to our first integration called SQS. It stands for Simple Queue Services, and what is actually it is, it's just simple queue. Imagine going to the bank, for example. You would come to the line, you would wait for your turn, and once the clerk calls you, you'll step forward. This is, again, fully provisioned service. You just create the queue, and you really don't care anything about it. You just, again, pay. But it's extremely cheap. This is one of the benefits. How this would look? Well, again, our payment service would then send the message to the queue, in our case, AWS SQS. But invoice service will periodically ask queue, does it have any messages? Meaning it's poll-based, it's not push. So invoice service calls, hey, are there any new messages? AWS SQS will say, hey, yeah, I have some, and we will get them and start processing, creating the invoice. This way, we have decoupled our services. They don't care about the response time. We have increased the throughput, but also if the invoice service has some problem or we are doing the upgrade, payment service will keep doing processing the payments and posting them to queue for later processing. Now, to understand a little bit about SQS, because it's important once we will come to the code. Invoice processing service issued the poll from the queue, right? And it gets the message, but something called visibility timeout starts ticking. And this is the period of the time that the message is invisible to another consumer, meaning that you have three services, invoice services scaled horizontally. If first one picked it, the other one won't be able to see it during the visibility timeout period. If you are processing, for example, message and visibility timeout passes, this means that other instances will be able to see this message. This is not something that we want to do because, again, we are wasting money on redoing the work we already done. After we are finished processing the message, we need to acknowledge it, meaning we need to issue call to the queue, say, hey, please delete it, so other consumers cannot see it. How would this look in real life? For example, you have two pods, two instances. First instance will issue the poll, it will get the message, and imagine that we don't have any more messages in the queue. Visibility timeout is starting, it's ticking, and if pod 2 calls to poll, it will get nothing. It will get empty response. When you think about this, building this inside of your framework means that in every library, in every code you write, you need to write polling mechanisms, which is bug prone. You need to write support for acknowledgement. Also, what about visibility? Can you extend it or not? It has a lot of use cases. One important thing about SQS, it has two modes. First is standard, second one is FIFO. FIFO is simple, means first in, first out. And as you can see, message group ID, as shown in top left corner, when you're sending message to the queue, you need to pass the message group ID as well. And this ID basically groups the messages inside under this ID, and then they're in order once you're processing them. This, of course, means that you're going to have less performance, less throughput than a standard one. Standard queue is basically, they don't guarantee the ordering. They try to order them, but they are not really responsible if they don't order the messages. And because of this, naturally, means that you have higher throughput. You would then poll and get the messages in order, and that is it. Since Spring Cloud AWS tries to be similar to other integrations, maybe you used Kafka, RabbitMQ, this means that you just need to place one annotation to start listening and receiving the messages. And this is called @SQS listener. You want to pass the queue name, and we are going to immediately serialize the object for you. For example, payment, because we are receiving the payment in our invoice processing service, you can then create the PDF, and that is it. One issue happens then, like imagine that you're creating the PDF and that you notice that you won't have enough time, that visibility timeout will expire. Well, first thing you can do is inject the visibility object inside of your meta signature. You can then simply call change to and change it to the amount of seconds you want. In our case, we are extending it to 400 seconds. If you want to change default SQS listener visibility second period, you can just put it inside of annotation. For us, it's 150 seconds. Now, polling is a little bit interesting. It's really complex. I could have a whole conference just talking about how to tune AWS SQS performance, but I will just try to simply explain it. Firstly, you will notice something called max concurrent messages. So these are the number of messages you polled inside of your Spring application and which are not acknowledged yet. Meaning, on the next poll, if you already polled 20 messages, none of them are acknowledged. We do polling in background tasks. Since the 20 messages are already acknowledged, we are not going to do the poll. If you, for example, acknowledge 2 out of these 20 messages, meaning that you have 2 left because 20 minus 18, then we are just going to poll 2 messages. Max messages per poll is how you are basically configuring the message, how many messages you want to poll in the single polling, right? Maximum is 10. This is limited by AWS SQS. 1 is the at least amount that you can do because otherwise it does not make sense. And you can this way configure the number. Poll timeout seconds is curious thing because this is the number of seconds we will wait with the request. Well, actually AWS will keep your requests when it's searching for the messages inside of the SQS queue. This is called long polling. Basically, you're giving them more time to return you 5 messages. Sometimes they may have 3, but they will wait for 20 seconds. Maybe they will return you 5 afterwards. Okay, what about the acknowledgement? Well, if you don't specify anything in an annotation and your method does not throw runtime exception or just ends successfully, we are going to do automatic acknowledgement for you. But if you have runtime exception failing this method that is annotated with an SQS listener, we are just going to not acknowledge it because, right, it does not make sense for us to acknowledge it. Your method has failed. This is why we support manual mode. Meaning, in your annotation, you would put acknowledgement mode to manual, and then you will inject acknowledgement object and just call acknowledge. You will then acknowledge manually if you have use case, for example, that requires this, you can play with yourself. Just remember that you need to do it then on your own. Since Spring Cloud AWS SQS is built on Spring messaging, we are trying to keep aligned with Spring Boot, right? We have built everything upon message object. Message object basically has a payload and headers inside. So if you don't want to inject the payment, etc., you want the headers as well, you can just inject it as a message. If you're interested only in headers, you can inject message headers, and we are going to automatically just give you a hash map with all the headers included. You can just use get method then to get whatever you need. In our case, this will be a trace ID. It can be a JVT token or whatever. Since using AWS SDK client to send messages is not really that easy, we have created SQS template. We configure this out of the box, and behind the scenes, it will use AWS SDK client, which is automatically configured with your credentials, region, whatever it needs. You can just inject it and use the send function and specify your queue name and the object you want serialized. We are then going to serialize your object, send it to the queue, and so on. If you want to send, for example, to a FIFO queue, well, we have function-based support for this. In SQS template, in send method, you're going to have function base. You're going to, for example, as you can see on the line, you can specify message group ID. In my case, it's really stupid because you don't really want to do ordering for company name, but whatever your use case on the job requires to, you specify the ID there. And delay seconds is the option if you don't want message to be visible immediately in the queue. You can specify a certain amount, and this is the amount of time that once the message arrives to the queue, it won't be visible. At queue, you need to specify queue as well, name of it. Notice that FIFO queues need to end with .FIFO, and payload is your normal payload which you want serialized. Of course, sometimes this is not enough, right? Because we have now shipping service. We need to actually send the box to the customer. And now, if we would have like payment service send to this queue, it's not really best practice, right? What if first message was successfully sent to the first queue, to the second queue it is not, right? It kind of brings some kind of transactional issues. This is why there's AWS SNS integration implemented. So SNS is basically, hey, I have an event, it creates the topic, everyone who is interested to this topic subscribes, and they get the message. How this looks in real life now, we refactored our payment service. Payment service would send the message to SNS topic, and then, for example, shipping service needs it to ship the box, invoice service needs it for creating a PDF file for invoice, and maybe statistics service just wants to have statistics. Well, it will use HTTP then to call these endpoints. For example, I don't know how about you, but for me, regularly packages don't come at my address at all because, well, shipping service says I was not home at that time. To avoid this, because this is bad customer experience, we will want to notify customer via phone that their shipment is coming. Well, you can use SNS for this as well. Now, shipping service will create its message. It will say phone number and the message it wants to send. It will pass it to the SNS, and SNS is going to send SMS to the phone. And this way we can say to the customer, hey, your shipment is arriving between 2 and 4 p.m., for example. But if you remember the previous slide, we had an issue because we still had HTTP communication. We don't really want to care about availability of our services. We want to decouple them fully. This pattern is called fanout. So payment service will send the message to SNS topic, and then you will create the queue for each service, meaning shipping service will have its own queue, invoice service will have its own, and so on. SNS will then send the message that you sent previously to each queue, so it's going to replicate it. And afterwards, you will have same polling as you did in previous example. Your services will then poll the messages, they will get it, and they will start processing it. To send the message to topic is extremely simple as well. You will eject SNS template. After this, you can use convert and send method. Basically, you specify name of your topic and your object. We are going to immediately serialize it for you, send it to the topic, and the rest is history. In case you want to send some kind of headers, for example, trace ID, or you maybe want to send JVT because it's going to be HTTP communication, you're going to use message builder. Since, again, it's built on Spring messaging, you will use the builder, specify which payload you want. In our case, it will be invoice. You can set, for example, set headers, specify trace ID, JVT. You can chain these set header methods, and that's it. Then after that, you build, and we are going to send it to SNS. When sending SMS, well, when sending messages to the phone, it's a little bit different. We have different template for this. It's called SNS SMS template. You then, again, have the same function. So you are seeing that everything is same. Everything is built on the same Spring messaging. You would use send, specify the phone number, and the string message you want to send. For example, courier will arrive today between this and this. If you don't want to use queues, if you want your service to be notified via HTTP directly, story becomes a little bit complicated. Firstly, you need to annotate your class with controller. And after this, we created 3 specific annotation, which probably it's kind of hard to understand, but we are extending request mappings for you. So every time you actually create REST controller, you would have REST, and you will have get mappings, post mappings, and so on. Basically, we extended these annotations, and first one is called notification subscription mapping. When you subscribe to the topic, SNS will send subscribe event. You need to confirm this subscription in order to receive the events that are actual messages. This is, so inside of the path, you need to specify the path that you will, when you are creating the topic subscription, you need to give it a path, endpoint, and this endpoint needs to match the path itself. After this, you need to inject notification status, as you see in message signature. You then need just to call status.confirm subscription, and that's it. We are immediately going to send confirmation to SNS. To receive the message, you need to annotate your method with notification message mapping. Again, you need to specify the same path as above. And inside of the method signature, you're going to have @notification subject annotation, which will serialize your headers, and notification message, which will serialize your message, meaning your payload, the main body. Then you can do your logic, depending what you need to do, and that's it. If you want to react on unsubscription event, you need to implement notification unsubscribe confirmation mapping. You will need to use this annotation, actually. You will annotate unsubscribe method with it, and we are going to automatically unsubscribe you. But if you wish to resubscribe because you think it's a mistake, you can then use notification status and call confirm subscription again. It's a rare case. I have not personally seen it, but since it's framework, we need to support every possible use case. Storing files, well, it's an interesting problem because if you run your, for example, if you run your services in some kind of container service, you cannot save them on pod, really. If you run them on virtual machines, saving them will just be deleted after virtual machine is deleted. IBM has really great support for file systems, and usually when you have on-premise, you are using some kind of their service, at least that was my use case. But on cloud, you will use something called S3. S3 is basically object storage. It's not file system, it's object storage, where key is the name of your file, and the file, well, value is your file in input in byte array. Now, we had invoices, right? We would create the PDF, but we need to give our customer some kind of access to it. Well, we need to save them somewhere first. In our case, we will create the PDF file, and we will just upload it to S3 bucket under certain name. We can then specify the key and just download the file itself. The most popular use case would be then to present this file to our customers, right? You will have, for example, your user as a front end. It would actually call API gateway, which you don't see on this picture, but imagine it did not fit. Then it will call invoice service, and invoice service will call S3 bucket to download the object, well, file. It will then download the whole file, pass it to API gateway and to the user. This is not the best use case because we are then downloading the whole byte array firstly in our service, then it goes through API gateway, and it's really not cost effective. We are spending really much money here. Instead, S3 has really cool support called signed URLs. Invoice service can create signed URL with expiration date, and it can pass it to the user. User can then use this URL, for example, to download the invoice, and only the user with this URL can actually download the file. You can also use signed URLs if you want to allow the user to upload the file. For example, if user was uploading directly to S3 bucket, you can create a signed URL, give the user URL, and then they will have rights to write to this for this given key. Now, this is the most common pattern you will use with S3s. Imagine that we are building YouTube, right? We have some kind of video service, and it's uploading chunks of video file to S3 bucket. And now we have some kind of resolution scaling service. As you know, YouTube supports resolutions. You have many resolutions. And we need to scale this chunk down, like it needs to be a lower resolution. If video service would call resolution scaled service directly via HTTP, we have kind of issue because we have, again, transactions. What if storage save upload was successful and HTTP call was not? What if resolution scaling service is not available? And so on. Again, sending it to the queue immediately after brings the same problem. What if queue is not up? What if the sending to the queue fails? What if our service fails abruptly? To solve this, there is something called S3 notifications. Basically, on put object operation or update, well, in our case, on upload, S3 bucket can notify certain destination, in our case, queue. We can then listen to this queue and go to S3 bucket with the location of the file that changed or was uploaded, get it, scale it, and put it back in the bucket. When you are creating these notifications, you can say, okay, for the certain path, well, certain structure of the key, regex, imagine it like this, please react. For certain paths, don't react. So when the resolution scaling service will actually scale the file and upload it back to the bucket, it won't trigger, again, SNS notification. This is, imagine a message as just saying, hey, this bucket and this location was uploaded. And you can just react to it. And this is the way you actually want to build event-driven systems with S3. To upload the file, it's extremely simple. You would inject S3 template. You can then use upload function and just specify the name of your bucket, the key value, and the input stream. Now, this is coming to be a little bit complicated again. Behind the scenes, we are going to be using in-memory buffering S3 output stream, meaning we will try to fit your file input stream in the memory, and if it's not too big, we will do it in one upload. If it's too big, we are going to do multi-part. For huge files, this is really problematic because you will just crash your application because of it. This is why we support also disk buffering S3 output stream. So if you need to handle big files, when creating, you won't be auto-varying S3 template. You will have to create a bin of your own. And you will mention disk buffering S3 output stream as an option for uploading. This will save it firstly temporarily to the file and will basically load it bits by bits and be sending it that way. Transfer Manager S3 output stream, we'll talk about it a little bit later, but just remember it exists. If you need to put some kind of metadata to the files, for example, content type, maybe the owner, or you just want to timestamp it when it was created, you can use Object Metadata Builder. You will use same upload function. You will just use metadata builder, content type, metadata, and so on. S3 is usually used for big data lakes. So you will have huge JSON files there for data mining and so on. If you need to store huge files, huge JSONs, you can use a store function. And we are going to basically serialize the JSON object for you into the JSON format. And this way, if you are doing big data, can easily process it. Now to download file, it's relatively simple. You still use the same S3 template. You use function download. You specify your bucket name, your key, and we are going to create you the S3 resource. If you use Spring files, you will know that everything is resolved to the resource. Again, we are aligning ourselves to the Spring Boot. Once you call resource.get input stream, we are actually then going to download your file. S3 resource is just the location. Get input stream is actually starting the download. then you can read it to the bytes, do whatever you want with this file, right? If you need to read big JSON files, we support the read function. You just, again, specify your bucket name, key, and the class you want us to serialize your object. We talked about signed URLs a lot. And we talked about is the best way to let our front end and let our users download the file. You can use S3 template to create signed URLs. Basically specify the bucket name and key. Pattern is the same. And specify duration. Duration depends on the credentials, but usually you will use short-lived credentials. For example, 5 minutes or 10 minutes is enough. If you need to get some kind of file on the startup, for example, you're creating some kind of REST template or web client, and you need to use certificate for authentication. What you can do is use @value, it's familiar annotation. You specify S3 prefix, and then after this bucket in your name of your key. And once you're creating the web client, then you can use, for example, certificate to configure it immediately. This is one of the use cases we support as well. If you require high performances, meaning you want reliability and performances when you're downloading and uploading the objects, you can introduce a dependency called AWS CRT client and S3 transfer manager dependency. Transfer manager input-output buffering stream, if you remember it, is basically only going to be introduced with S3 transfer manager dependency on a path, and it is going to speed up your uploads and downloads really much. So I really recommend for you to use this. If you need client-side encryption, for example, RSA or KMS, I don't care, you can introduce S3 encryption client dependency inside of your code, and we are automatically going to configure that each of your downloads are going to be encrypted/decrypted, depends on your operation. I used this only once in my career, S3 Access plugin. It's when you need to have a fine-grained access control over your files. And usually you will only see that if you have like huge buckets with a lot of customers. Your IAM roles, which protect your bucket, have certain size limits they can achieve. And if you are hitting that limit, you will need to switch to Access plugin. When I was starting my career, I read a lot of books from Clean Code to others, talking about disasters of companies that had configuration mismanagement. They would spread their configuration across the whole organization, and this usually ends up with no one knowing how application actually run. They would not be able to modernize, and basically whoever came could not, they had to end up with the whole rewrites. This is why we have one of the great, at least for me this is my favorite integration, to centralize all of your configurations in one place. You heard probably about Spring Cloud Config, and the issue with Spring Cloud Config is that you have to manage your own services, meaning you have to manage availability of Spring Cloud Config, you will need to host it somewhere, and so on. Instead, you can use S3 bucket. What we do for you, before application context phase even starts, we'll go to S3 bucket, we'll download, for example, application properties, application JSON, YAML, whichever you prefer format most. We are going to download this file, and we are going to enrich your environment for you. Meaning that if you use Spring Data JPA, if you in application properties you have, for example, URL, password, and username, we will download it before context is started, and we are going to configure data source immediately for you. How this looks? Well, for people that use Spring Boot from 2.4 and above, you will use Spring Config import. You will prefix it with AWS S3, specify the bucket name, and the key. In our case, the key is just config properties. We are going to issue the download it, and then enrich your environment variables. If you see it by red, it's a semicolon. You can download more files, and you're splitting the files with red semicolon. You will have bucket name and application YAML as a second file to be downloaded. Because if you don't find the file, we are going to, crash your application. we are going to stop it from reaching application context phase. And if you don't want this, you can mark the prefix with optional. This is the green text. And if you do this, we will just ignore that file does not exist. Since storing really of secrets is not really a great place for S3. You don't want to store your username. You don't want to store your passwords to the S3. AWS has this cool feature service called Secret Manager. This service is fully hosted for you, provisioned again. It does all the encryption, decryption for you. And you can safely store secrets there. It's similar like Vault. So we support the same, actually, integration. Before application context phase has started up, we're going to go to Secret Manager, download the secrets, enrich environment, and then you can use them for plenty stuff. For example, imagine that you want to load database secrets. You will specify AWS Secret Manager as a prefix. For example, in our case, it will be pre-prod secrets, database secrets will be the name of the secret. Inside, the value would be some kind of hash map JSON format. For example, it has password and username in it. And it would basically be resolved to, you could, get it by using @value annotation, reference it as a password, or you could use configuration properties, like you manage your properties from application properties which are located in resources. Since this won't actually configure Spring data source, right? We introduced a prefix, this green text. You can prefix your secrets. For example, in our case, it will be Spring data source. So if this is our secret hash map, this is how we will be able to retrieve them inside of our code. Meaning, if you use Spring Data JPA, it will automatically configure data source bean for you. If you don't want to store whole file, for example, you just want to store some kind of parameters because application properties are usually static. They have really rare changes in them. For example, URL will change and things like this, but most of stuff will be static. You can use parameter store. It's basically AWS service for storing the parameters, which you can then use again for example, for URL or whatever you want. It's a key value storage. This is how it looks in AWS console. In our case, we have prod database URL, which is the name of our parameter. We would use, again, Spring config import. It would be just AWS parameter store as prefix. And interesting here thing is that we are loading by the path. We are not loading by the key. So you have /prod, /database/, and everything on this path will be loaded. Meaning in your code, you will access it with like this, @value and URL. Let's spin it a little bit. What if we ended with /prod just? But then in your side of your code, you will access it as a database.url. But I really don't like that you have to create your parameter names in order to resolve them to the Spring, for example, Spring Data JPA standards. So this is why, again, if we have this prod database URL, we have same prefix support. And if you loaded it, if you have the load that ends with database/, in code, you could reference with Spring Data's URL, meaning that you don't have to create your parameter namings based on actually being required values. If you have, for example, let's say we are kind of building some kind of security endpoint, and it says it's using basic out. You want to rotate these secrets really often, like maybe every 7 days. I have seen applications that are running for 5 or 6 months without crashing, meaning that changing the parameters is not that easy. This is why we support reloading of secrets. We will periodically go, for example, in our case, to Secret Manager, pull the secrets that you have mentioned in Spring config import for you. We will retrieve these secrets, and if we detect the change, you can either choose restart context, you will have small downtime, we will crash down your application context and restart your service. Or if you use refresh, we are just going to swap the beans that are affected. In our case, we had Spring data source. If you change the password, we would create the new bean behind the scenes. all the beans that are using data source will start pointing to this new bean, and the old one we are going to be removing. You can control poll period with Spring Cloud AWS Secret Manager reload period. If you want to use parameter store or S3, you just specify S3, for example, instead of Secret Manager. And now testing. On previous session, we heard that testing should be the first lecture on the university, and I agree. Why is testing important? Well, firstly, it allows us to catch bugs sooner. It also helps us to make our code more maintainable. For example, you have some use cases who, like people, when the newcomers come to these projects, you don't understand anything. And first thing, they're probably going to check tests. And if they create some kind of new use case and they implement it, they might break the old use cases, and this is why tests should catch this. Testing on AWS is not easy, because this means that you would have to hit AWS inside of their data center, which you don't want. This is why we have support for test containers. Test containers is this small library which will run Docker containers in your testing, meaning that you can do integration testing with it. You can put in these containers Postgres, Redis, Kafka, whatever is your use case, but we want to put local stack container. Local stack is mocked AWS service, and it basically mocks the usage of real AWS. So if you want to do integration testing, you can do it with local stack. You can see that it's annotated with add bean and service connection, meaning that we are going to configure all your S3 templates, SQS template, all the SDK clients we created to point to the local container immediately. Meaning, in your GitLab CI/CD, for example, you can run your integration tests. We will leave the Docker container, and we are going to point to this container for you. Some other supported integrations that I don't have time to talk about today is DynamoDB. We have simple wrapper for DynamoDB client. It removes some kind of boilerplate code when you are resolving the table names. Simple email service integration to send emails easier using Java Mail client. We also support sending of CloudWatch metrics, Spring Modulate, and instance metadata service for fetching the instance metadata if you, for example, are using EC2 virtual machines. And we support GraalVM hints out of the box. Some planned future enhancements we planning to introduce on the project is observability. For example, for SQS will be the first integration we plan to add automatic observability. We are going to propagate the traces and so on. We also plan to do it on SNS next. Event bridge integration. We are planning to support creation of cron tasks and event bridge template. And we are going to plan on supporting CloudMap. There is already PR for it, but we did not have enough time to check it yet. Since this is a community project, meaning it's not sponsored by AWS or VMware or anyone, it's actually 3 of us doing it in our free time. It wouldn't be possible without everyone who contributed to the project, be that open issue, discussion, create a PR, or just comment on the pull request. And because of that, I would like to thank everyone who contributed to the project. And I hope really that you liked today's presentation, that you maybe learned something else. If you want to check the project, here is the QR code. And if someone has the question, I'm free to answer it now or later. Okay, yes? SNS or? Okay, I will go back to this 1 second. Basically, SNS has inbuilt retry mechanism. It will try up to certain amount of retries. Okay, we are to this here. So if, for example, shipping service is offline, SNS will try to send it. Okay, it cannot achieve it. It will go back. It has internal queue, and it will try up to n times with the backoff policy. For example, every 5 minutes, then next time will be 20 minutes, and so on. And if it fails to send it after a number of times, you can create SQS queue here, and it will go to the letter. And that's it. So it's done by Amazon for you. You don't care. Also, you need to send like successful OK 200. Yes? Oh, sorry, can you repeat, please?
Do you need to have separate applications for every region you want to use AWS in? Because I guess you need different accounts and you need to get different secret for this, right?
In what terms? Like you want to run like...
So you can have one application for, let's say, Europe, right?
Okay.
And then you need to have separate applications with different secrets hosted somewhere else.
Yes. So we would have a multi-region setup. You can have calls to when you're setting AWS SDK client, you need to give it a region. For example, I want this client to call only EU Central 1. If you want to access US, you would have to create another SDK client and make the call. Usually, if you want to run multi-region setup, you would have to replicate secret manager secrets like there and there. Or you would call Europe if latency is okay for you. But usually you will have 2 applications hosted on 2 regions and just have DNS depending on this.
And all the AWS resources you're creating manually, right?
Sorry?
You create the AWS resources manually.
No, you can use CDK, which is, imagine writing Java, and you create, hey, I want S3 bucket, S3.bucket, and you use Java like builder. Or you can use Terraform. Terraform is YAML language, and you can specify which infrastructure you want. For example, S3, RDS, whatever, and it will automatically build for you. Or if you are playing out, you can use AWS console.
Yeah. Okay, thank you.
Yeah, thanks.
Дигитален зум двоен, защото не знаехме тук къде ще очакваме да се седнем отзад камерите. Тук сложихме 70-200, то пък там не трябва много повече. Другата зала, да. Anyway, има бургери, ако искаш бургери.
Session about how to simplify your life integrating SSO with Quarkus OIDC. In setting up SSO is typically always a hard topic for pretty much everyone, developers, QA. So, William, you have the word to tell us how to simplify that.
All right, thank you very much. Thank you for having me here. First time for me in Sofia. I'm Willem Jan, I'm Dutch. I'm based in Delft in the Netherlands. My company is called Lunatech and we do a whole bunch of JVM and cloud stuff. And we're based in the Netherlands and also have an office in France for our French-speaking customers. Today I'll be talking about single sign-on and how to make that easy. A lot of people already think, oh, that should already pretty easy, you just click a button and it should work. But you'll see that some providers are a bit more tricky than that. And also go a bit behind the scenes to see what's actually happening with single sign-on. And in the end, I'll show how easy this can be with Quarkus OIDC. You can probably do the same with Spring or any other framework, but I'm a bit more familiar with Quarkus. So today I'll showcase some cool Quarkus features as well. I hope if something breaks, you guys can help me out with the coding, and let's see how that goes. Today's agenda. So why do we do single sign-on? What is OIDC actually? What does the abbreviation mean? What does it do? Why do you have access tokens and ID tokens? What's the difference between them? Then we'll dive into Quarkus and Quarkus OIDC, how we can do that. Have a look at the dev services to ease your work and testing in dev mode, to actually have authentication with a real provider in dev mode as well. Do testing, and in the end, if we have some time, go to production. So who here built his first user registration system? Who did that before in the past? Building a registration system to register a user, register the password, whatever, was probably not that easy. Initially you think it can be easy, I just need a name, a username or email, and a password. Then you need to think, how do I encrypt it, how do I store it, blah, blah, blah. Then what about user activation? So I need to have some email service or some verification service with a phone number to verify the user. Then you have all those users that forget their passwords. So you need to have a password reset. Then nowadays it's more common to use 2FA or MFA with a second factor authentication. The users lose these as well. You have WebAuthn, passkeys, whatever. It's getting more tricky and trickier when you start to think about it. So that's why we typically delegate this to a central system that's really specialized at this. If you have your personal accounts, you probably have a Google account or a Facebook account, and you can log into the entire internet with it. Even your grandma or your mother can probably easily do this. Just click a button, doesn't have to remember a password anymore. It just works. For your typical enterprise, you probably don't want to log in with Google or Facebook. You probably want to have your own provider. Lots of places use Azure AD or some on-prem Azure, maybe Okta, or have their own Keycloak cluster running themselves. Also with single sign-on, we have stateless token validation. Back in the days, you had those tokens that needed to be validated on the backend with some other service. That service went down, and then you couldn't validate the access token anymore. With OIDC or OAuth2, you can simply validate those tokens without needing the extra service. So, what is OIDC? Well, it's going to be a lot of abbreviations, and I hope to make it a bit easier for you guys today. OIDC stands for OpenID Connect, and then you probably still don't have a clue what that means. It's basically an open standard. It's an open authentication protocol. And it's basically an extension of OAuth2. OAuth2 is more about authorization, and OpenID Connect, as the ID says in OpenID, adds the identity layer. So next to that we have an access token. With OIDC we also get an ID token. And then we'll see later what the uses of an ID token and access token is. So how does this typically look like? We have some user, he wants to get some application data, but he's not logged in. The application does some authorization request, delegates that to our OIDC provider. In this case, it's Keycloak, an open source component. That one is going to actually request authentication. It will probably do simply an email password, but can also delegate it to a third party again. For example, at Lunatech, we have some Keycloak servers running there as well, but we use Google Workspace as a primary source. So Keycloak then delegates again the authentication to Google Workspace for us. That's how it then all works together in the end. In the end, the OIDC provider returns an authorization code. The application can exchange this with its client ID and client secret for an access token, ID token, and then use that on behalf of the user, or set that as a cookie for the user. We'll dive into this a bit later, but the key takeaway is that our application itself doesn't deal with username passwords. It's our third-party OIDC provider. There is, in this domain, as in every domain in IT probably, a lot of abbreviations. I'll cover a few here. We have OIDC, well, that's OpenID Connect. Then we have OAuth, that's Open Authorization. Then we have an IDP, that's the identity provider, so Google, Okta, Keycloak. Then we have a JWT. Some people call this a JOT. I don't know how you make from JWT a JOT, but that's how a lot of people tend to pronounce it as well. That's the actual token in the form of a JSON token. Then we have the JWS, that's the signature of that token. Then we have the JW key, that's the key that was used to sign the token. Then we have the JWKS, that's the key set, because your OpenID provider typically has multiple keys, so it can actually rotate those keys as well. And in the end, we have RBAC, that's role-based access control. That we're going to see that a bit later as well, how you can delegate then different permissions based on this model. We'll probably see a bit more abbreviations, but I just wanted to cover a few of the basic ones. In this domain, we typically have two kind of applications. We can have service applications, basically a bunch of backends that talk to each other, that need a token to authenticate, or you have a single page application that needs to talk to a backend. Then you typically use bearer token authentication, so you put in your header, you put this bearer token, and you can authenticate with that. And the first service that receives this token can use it, but it can also propagate to multiple services in your backend to actually use that token. What we also have is your typical old school web applications. They use the authorization code flow, and they're great for server-side apps. And today we're going to see a bit of a combination of both, but I'll mainly focus on the server-side apps, but the same goes for single-page applications. This is the typical example for bearer token authentication. It's probably a bit small in the back. Let's see if we can make it a bit bigger. Yes. So we have the single-page application. My user accesses that single-page application. It uses, again, the authorization code flow to authenticate the user and get the tokens from the OpenID Connect provider. In the meantime, when this Quarkus application that's running on your backend started up, it got the verification keys, so the public keys that were used to sign your token. And when it gets that token, it can actually validate it. And if the tokens are valid and signed properly, then it can actually return the data to the user. And of course, we can have Quarkus servers 1, 2, 3. There can be a lot of chains in the backend. It can fan out and use those tokens as well. But the key takeaway here is that the authentication, again, is delegated to OpenID Connect provider, and the applications themselves don't really deal with any form of authentication. They just propagate the token for you. Then we have the authorization code flow. That's a bit bigger. So we zoom in that as well, if we can. No. Yes. So on top, we have again our Quarkus user, and in this case, we don't have a single page application, we just have a server-side rendered web app. It tries to get some application data. The web app figures there is no valid cookie, so I'm going to redirect you to our OpenID Connect provider. This one is going to do this authentication flow, so username, password, MFA, YubiKey, whatever you name it. It gets you, redirects you with an authorization code. The Quarkus web app can then exchange again this authorization code for an ID token, an access token, and a refresh token. And optionally, this backend can use this access token to get a bit more information from the user. Your token is probably not too big, and if you want to store, for example, a profile image or a link to something else, you can retrieve that data on behalf of the user. Well, we combine it all together, create our custom session, create a cookie, and from that cookie, then the user is authenticated and can actually get his application data. Let's see. Yes. And of course, you also have the option to do a refresh token. So in the meantime, if your access token actually expired, they're typically short-lived, nowadays only a couple of minutes, you don't want to prompt the user to log in every time. So you leverage refresh tokens, and they can be exchanged again for a new access token. And they can all happen transparently in the backend without the user knowing. Now, I'll mention a couple of different tokens. We have the ID token and the access token and a refresh token. But what's then really the difference between an ID token and an access token? So the name already says it. ID token is to identify the user. The specification is from OpenID Connect. And it basically says the user has been authenticated. We know this user exists. This is its name, this is its email, etc., etc. So what can we do with this token? Assume the user is authenticated, get some profile data that was in the token to display it, and you can do that in both traditional web app, but also in your single-page application. Use this ID token to show some basic stuff about the user login. What we shouldn't do with an ID token typically is call another REST API with this token, because we can't really know what it's about. We have an access token for that. An access token, it determines what kind of access does the user have. This specification is based from OAuth2. And with this token, we can actually call another API on behalf of the user. And we can check user access. So typically in this token, you're going to have the roles of a user. Is it a user, an admin, a super admin, etc. And you can use those in a safe way to assume user access. What we shouldn't typically do with those tokens, inspect those tokens. Keycloak, in this case, returns also JWT that we can inspect because it's just some JSON data. If you go, for example, to Azure AD, they will issue a so-called opaque access token, which is just a random string of gibberish, and you can't really check what's in there. So you can't see the user email, for example, from that token. That's why you have the ID token in that place. And only Azure themselves can actually validate this access token. So if you on the backend want to inspect this opaque token, you typically have to send that token to Microsoft or another IDP to get some information about this token. Is it still valid, etc. Then we have a token. A token is a whole bunch of gibberish, but there's 3 different bits. Separated by a dot, and the first bit is a bit of meta information. So it contains the data about what signature was, what key and what signature was used to sign this token. So you can combine and validate using the right keys. And we're going to see that in a bit as well. What typically is in that token then is a whole bunch of claims, and those are just your JSON values. So we have an expiry, an issued ad, the issuer, so in this case it was a local service, the audience, it's my Quarkus application, and the audience is quite important as well. If I get a JWT from a random service as an access token, it says like, my fake application, I should probably not use it because it was issued for the wrong application. That's why you should also verify the audience. Was this token actually issued for me or for someone else? And then, I mean, on the back end. If it's issued for something else, you should probably prompt the user to log in again or to re-authenticate. And in this token at the bottom, so you have a whole bunch of meta information. We also have the groups for the user. So we can see this Alice is an admin and a user. Then we're gonna look into Quarkus. What does Quarkus do? How do we use it? And a little demo as well. Who has used Quarkus here before? It's not a lot of people, not in production, but that some people just play with it, that's fine as well. Then I'll probably go over some basics as well to explain you what it does, what it is. Quarkus is a modern web application framework. You can build any type of application in that. It doesn't have to be natively compiled. You can run it in Docker containers on your classical application servers. And it's really meant for developer joy as well. Where we're going to see how easy it is to do stuff in your dev mode, test mode, but also how easy it is to go to production. And it's really tailored to cloud-native applications, but you can also just use it for a traditional web app as well. That's what we do for some customers as well at our job. If we then have a look at code.quarkus.io, yes, that's fine. If you're familiar with Spring Boot, they also have a website like this where you can generate your project. So we say org.jPrime, say Quarkus, single sign-on DC. We'll make it a Maven project. Now we want some REST endpoints. We want OIDC. That was misspelled. And then we generate it. Now we have a few options, download as a zip, etc. So if we download this zip, let's see, let's unzip. There we go. Then we can probably unzip this. As you see, yeah. Let's go to this. And of course, this is a demo, so IntelliJ doesn't want to do anything. Wants me to trust this thing. No. Oh, that's all right. So we scaffolded this basic project. We can have a look at the POM file. We just have a Quarkus project configured. We have the extensions that we selected here. Some test extension, and that's it. It also generated me some sample code. So if I look in there, I have my, let's trust it, then I can actually render stuff, yes. So in here, we have our basic project with your typical JAX-RS endpoints, with your annotations, with get and produces. The nice thing is, if you're familiar to Spring, you can also use your Spring annotations here. If you add the extension, then you can use get mapping, post mapping, all that kind of stuff, and it will just work as well. It will silently at build time transform them and make them work. The configuration is empty, there's nothing there. And there's a basic test that validates this endpoint. That's all there is in this sample project. If I then run this using this Quarkus CLI, so we can use this Quarkus CLI, Quarkus Dev, or if you're more used to Maven, then it uses Quarkus Dev as a Maven goal. And we're going to see what it does. It's going to build our project. And immediately when it starts up, it already does a lot more things than you would imagine. You see some whole stuff about Docker, but we didn't configure anything for Docker. And those are the Quarkus dev services. So it detected that I had this OIDC extension. And for this OIDC extension to work, I need some IDP, so some identity provider. I don't have anything configured. We're in dev mode. I have Docker enabled on my Mac. So I was going to say, well, let's download a keycloak image and start that for you. Let's see. And then we have our basic web application here. Our first application. As simple as that. We'll show you what endpoints we have. Next to that, it also comes with a dev UI. So this has some cards that show you what things you have enabled. So Arc, that's the dependency injection framework used by Quarkus. Then we see you have OpenID Connect enabled. We have REST based on Jakarta REST. It uses some stuff under the hood. And we can have a look what it did here. If we have a look at the magic, what it did here, it started this Keycloak container for me. I'm using Podman as my Docker daemon, and it configured those things for me automatically. And because OIDC is a security thing, we get our good and old Alice and Bob. And all the examples that you see with security-related things, they always talk about Alice and Bob. So these will pre-configured users in your application. And if we want, we can actually have a look at that instance. We have this card here called Keycloak admin with the very safe username and password admin. You'll see Keycloak will complain about it, but that's for a local environment, that's just fine. Let's have a look what we have in here. So we have the master realm, that's just to administer Keycloak. And here we have our Quarkus realm, and we can have a look what we have in there. In here, we have our good old users, Alice and Bob. Those were automatically configured for you. You can adjust the configuration for you as well for dev or test mode. If you want to have some, if you ever have some personas in your application, like an admin user, a finance user, a read-only user, you would create those personas or users, and it will be automatically propagated for all your developers for dev mode, but also for all your tests, you will have those users ready. What else do we get? We get a client. We have here our Quarkus application. Well, normally you would set up the home URL, valid redirect URLs to only your application, so not everyone can use this client application. But in this case, it's dev mode, so we just allow anything. And in here, you can then have a look at the secret. So the ID is Quarkus app, and then the client secret is secret. And you're going to find these things on the Quarkus UI as well. So here we have our Quarkus app and Quarkus secret. It also injected the auth server URL. So that's where the Quarkus OIDC extension knows where to look up things. So it automatically injected that as well. Typically for production, you would configure this to point at Okta, Google, or your production Keycloak. What else do we get here? We also get continuous testing. The first time is going to take a bit of time because it's going to spin up yet another Keycloak. So we have one Keycloak for development mode and another Keycloak for testing mode, so they don't interfere with each other. In this case, we only have one test. But Quarkus is smart enough. If I change some pieces of code, it will only run the test that will actually affected by this change. So on the first time it starts up and starts running my test, it introspects all the code, makes a nice graph, and then it knows if you change only this bit of the application, I only need to run those tests, and that will really speed up your development cycle as well. So if I now, for example, change this test, already you see that it failed, and if I now revert it, it should be good again. So this is how quickly it works in the background. If I see my terminal logs, I see the failure here, it quickly rebuilds, and the tests are green again. Now, of course, this is a dummy example, but even if you have bigger applications, this typically works pretty smooth and pretty fast for you as well. So you can really see the cycle of you as a developer. You have built this little project, you give that to your colleague, he just does Quarkus dev, and it runs. No more manual Docker compose, importing some production data, whatever. You just have the whole entire setup for you in your repo for dev mode and test mode, and later as well for production. And you get all those goodies out of the box. As we can see again, I really didn't configure anything here. So I didn't put anything in my application properties, it was just done magically for us. And that's what we see again if we go here. those were injected for you automatically by the Quarkus dev services. If you now, for example, have a database, it can do the same with a RabbitMQ, Kafka, you name it. There's a whole bunch of dev services that can auto-configure for your dev mode and test mode automatically. Of course, I build a slightly more advanced example. So let's quit this thing. Let's wait for it to boot up as well. And you see here I have a bunch of properties, but commenting them out as well. Let's see if it now actually starts working. Yes. So again, I have my basic example. If I now visit the web UI, again, from this web UI I can also test a few things. So we already saw the Keycloak admin panel. But we also can have a look at the Keycloak provider. So we can say log in. It'll actually prompt me to log in. And now I'm logged in. I can now also introspect my tokens, as you saw from my screenshot before. And this roughly looks like what we saw before. It has all the data in there. And then we can also have a look at the access token. It will probably look roughly the same because we didn't configure much more. Now you wonder, how can Quarkus then validate this token? So as I said before, this red bit is the signature or the metadata. Then the green bit is the actual content. And the blue bit is the signature that Keycloak used to sign this token. So we can see if we copy this token, and we go to this website jwt.io. Don't do this with your production tokens. Although they say they do it only client side, but yeah, if it's real production tokens, I wouldn't trust that and never paste them somewhere online. We can have a look in here. I actually like the new UI a bit better. I can't switch. Yesterday I got the new UI, so they're probably doing some A/B beta testing. So here we got the header again and the data. But now we need some public key to actually be able to validate the signature. Did nobody tamper with our signature? Did they change the token and invalidate the signature? But you could say, well, I can also make this a super admin. And just try to submit that. But that won't work because now the signature is invalid. So we need to validate this somehow. How do we figure that out? I configured a proxy on my local machine to introspect my traffic. And here you can see a whole bunch of things going on. The first thing it does for the OpenID Connect protocol is to go to this. We saw this auth server URL at the beginning, /realm/Quarkus, and then it goes to this well-known OpenID configuration. That's based on the standard. Every IDP has this endpoint, and this endpoint will show you where to get the rest of the configuration. So the extension can auto-configure itself. Here we see a whole bunch of data, JSON structure again. So who's the issuer? What's the authorization endpoint? Where can I get a token from? Where can I introspect a token? Where can I get some user info, etc., etc. It also lists the things that it supports. We're not going to go into all the details, but OpenID providers typically support a whole bunch of things. And here you can detect what they actually support. If you look, for example, at Google Workspace, they also have an endpoint like this, and they will show you what they support there. Or from Microsoft Azure, they can also see what do they support in here. You see the token signing algorithms, etc. Well, as you can see, it goes on and on and on. This is not meant for humans, but for extensions like Quarkus OIDC to read this. Let's clear this. Let's starting it again to see from a clean slate. So it discovered from the first endpoint where to get the certificates, and then it makes another call to get actually the certificates. Those are the public certificates that Keycloak used to sign the token with. So we can introspect that, and here you typically see multiple keys, so that you can allow for key rotation as well. And it's not a kid, not a child, but it's a key ID. So it's the identifier of this key. And it's just your public key in base64 format. And you can use then that key, for example, in here to validate your token. That's what the extension does in the background. It gets this, first it gets this OpenID configuration. From there it discovers where do we need to get the certificates from. It downloads the certificates, then prompts the user for authentication. It gets back with these tokens. Now we need to know that the tokens that we have, are they actually valid or did someone tamper with them? And then we can use those public keys to validate those tokens. And that allows for stateless validation. Of course, when it starts up, it needs to know this public key. But yeah, that service doesn't have to be highly available for that as well. It can disappear or it doesn't pose extra load. Not for every request that your user make. You're not going to go for every request to this certificate backend again because you just cache that certificate. And that really helps scale as well. Let me see, what can we do next? Let's see. So we have our basic endpoints here. Let's revert all this stuff. We have a few things that we can add here now. So we can say, for my path, you need to be authenticated. So I don't care what role you have, but you need to be authenticated. This is again just your standard annotations for that. And then we can also inject a whole bunch of things with Quarkus. We can get the ID token. We can get the access token as well. In case it's an opaque access token, we can inject that as well. The refresh token, we can make the user information available. And Quarkus then provides a handy utility called the security identity that you can then use to get some more information. So for example, if we say, now we want to return the user that logged in, we say get the principal and then get me the name. So let's see if that works. So Quarkus generates this nice overview page for you in dev mode. Well, prompts me to log in. Well, I logged in as Alice and I get back Alice. That's what you would expect. We can have a look what happened to in the backend. Let's see. So this is the user info certificate. So during startup, it got this well-known information, our certificate. So you have all the configuration ready. Then it got this. How do you call this? Your authorization token. And it's going to change that for an ID token and an access token. So you can see here the authorization code and the actual code and where it should redirect you back. And here you can see the access token being generated, and there's some expiry time. There's an ID token, and it can also have a refresh token. In this case, it doesn't generate a refresh token because then it would have to add some more scopes. So you have some default scopes in there called email. For this protocol, to get an ID token, you need to open ID scope. And you can, for example, also add the offline scope, and you also get a refresh token that you can use. Well, we get those tokens now, and Then we want to look up some extra information from this user. So we have this user info endpoint. That's again documented in this well-known OpenID configuration endpoint. So Quarkus automatically knows where to find this endpoint. Then we use that previous access token that was generated for us as a bearer token here. And then we see some basic information about Alice. Well, in dev mode, it doesn't have a lot. I mean, we already got the groups and we already have Alice. But you can imagine having some extra meta information on the user in here. That's how we then get logged in. What else do we have? If we then say admin. So Alice is allowed to do this, but Bob should not be. Let's see if we can log in as Bob. We get an empty page, and if we inspect that traffic, network, yes. And we get a 403 forbidden. It's a bit small for in the back, but it says a 403 forbidden. We also get that from the access logs probably here. It's a bit more easier to read. That we here indeed have Bob that's logged in. Let's make this a teeny bit smaller. So in the HTTP access logs, we see that we have Bob there. He is logged in, but he's not allowed to view this point, so you get a 403 back. If you then have a look a bit more in the beginning, what happened? So in the beginning, Bob was not logged in. You see that he was trying to access authenticator/admin. It got a 302. And you see Bob is really not logged in yet, so he's not there. He gets redirected, and then there's this authentication dance with Keycloak. It gets redirected with this, this code in here. Quarkus then exchanges this code for an ID token and access token, sets that in a cookie for us, and then we can access this endpoint. However, Bob doesn't have the permissions to view this endpoint. What else do we have in here? Ah, yes. We can ask if this is an opaque token or not. Well, in this case, not an opaque token because we saw from Keycloak it issues normal JWTs. So we can actually introspect it ourselves. Is it again an opaque token? Then we should use the introspection token endpoint to inspect this token for us. Let's see, what else can we show? Let's close this. If we have a look in the dev UI, another neat trick that I recently learned at another conference at DevOps Belgium earlier this year, last year. If we now go in here and we say login, so Bob again needs to re-authenticate somehow. I enabled the OpenAPI extension, and it comes with a Swagger UI by default in dev mode. And we're now logged in as Bob. And then we can now go to the Swagger UI, and we can see that we are logged in here as well. So if you have your Swagger API documentation for your OpenAPI endpoints, you can actually, in dev mode, easily test this out. Otherwise, you typically would have to go and run some CLI or curl commands to get a token. But in this way, in dev mode, it's a nice extra thing for developers where they can just click and play and act as if they were an actual real user for the APIs. So I can actually try that, execute it, and we get back Bob, as we would expect. What else do we have? We can have a look at the user info. Well, this is the JSON representation of that user info. And that way it really makes it nice and easy to play with, because now I can also say like, well, log out. Somehow that didn't work. Yes, log in again. And I'll log in as Alice. Let's go in here, and let's see if Alice is still an admin. And indeed, there's the roles admin and user. Don't know why it's null. Probably broke that just before I was tweaking the demo. but it really allows you in dev mode to really play around without having you to do any complicated steps. You can just click and play and interact as different users. What else is there? I think that's it for the dev mode I wanted to show. Yeah, there's a whole bunch of different cards, so you can have a look at your endpoints, get some scores for your endpoints. So if you really want to go into performance stuff, you can scroll here and to see what you need to change and what they advise. And it's readily available for all the things you want to see. You want to see the exception mapper, so the forbidden exception is automatically configured. We can override that with a custom exception mapper, of course, to present a nice error page for the user. All right, I think this was it mainly for dev mode. I showed a whole bunch of things, but from what I started with, I just downloaded a starter project, didn't configure anything, run Quarkus dev, and it automatically spun up a Keycloak instance, configured it for me, and it just worked out of the box. So my presentation could also be in just 1 minute, showing that be done, and we could all enjoy the sun. But I hope it was a bit more interesting to see what's going behind the scenes, and to actually what happens with such an extension. What do we get from an OpenID provider? How do we get those certificates? How do we use the certificates to validate a token? And how do we actually use then those tokens? So this is what we saw, starting a Keycloak server, no configuration. You can also update those Alice and Bob users with some configuration as well. A new thing that what they recently added is running without a Keycloak server. As you can see, Keycloak takes around 30 seconds to a minute to start up. You might say that's not a lot, but Quarkus is pretty fast in dev mode, so that minute really bothers me sometimes. What you then can do is use the embedded one, where you then say Quarkus OIDC dev service is enabled. Then it doesn't run with a Keycloak server, but it will just run up an in-memory WireMock instance that can then serve those requests for us. And you can see that here we don't have any Docker stuff happening, and it boots up pretty quick now. Boots up in a second and a half. Then have a look at that. As you can see here, we don't have any Docker container configured, but it just injected this config for me, and we have again our good old Alice and Bob. But this way is even nicer, I think, because I don't have to guess what my colleague configured here as dummy users, but it just gets presented, what user do you want to log in, or do you want to have some custom user, but I can just click Alice, and I'll be logged in as Alice here. As you can see, it's Alice. So I think this thing that got released pretty recently makes it even faster and even easier to go testing. Of course, if you want to mimic something that's more like production, I would advise you to use the Keycloak dev services, but this can really boost up and speed up your development cycle as well. Now, how to test? We already saw some tests. It also spins up another Keycloak instance. And we can also use some test extensions. I'll quickly show that before time runs out. If we make some tests, we basically have our simple test here with rest assured. We say, well, if this thing happens, if I'm not authenticated and I'm not following the redirects, I should expect a redirect. So if I'm not authenticated, it should redirect me to Keycloak. That's one bit. And the nice thing is that you can slap on another annotation here. It says test HTTP endpoint, and it points to this authenticated resource.class, and it will grab this path automatically and configure this path automatically in your rest assured test. So I don't have to put those paths here myself, but the Quarkus test automatically pick that up and configure that for you. That's a nice little touch that got added a couple of years ago. In the beginning it wasn't there, but it avoids you having to write all those strings all over again in your tests. You can just use them, and if I update this, I don't have to update my tests because they're linked through this annotation. What else can we do if we revert this? It also allows for some nice annotations to test different endpoints. Because this is more like black box testing, I spin up some server and I want to test, can Alice log in? And does that actually work? They have this annotation called test security, where you can configure the user and some roles. So we have Alice and Bob again, but I can also reconfigure Alice to not have any roles, for example. You can expect different kind of things in here. And if you want to go crazy, they provide a more abstract annotation called OIDC security. And if you have a look at that one, you can basically put in any claim that you want. So if your application relies on custom claims in your token, you can also configure those during your tests. So you can say claims is foo and configure stuff that you want in there as well. That really makes it easy to test different scenarios if stuff is not present or is present. You don't have to configure all the test users, but just for this isolated test, it will generate a token with this information for you. What else do I have in here? So the only thing for that you need to add is the test security extension, and that will enable those annotations for you. And if we have a look at the tests, let's see if they run, and they actually are all running again. So I extensively covered how this thing works in dev mode and test mode with continuous testing. It really focuses on the developer to make this easy to test, not try this without authentication in dev mode and test mode, and then figure out in production or some QA stage that the authentication or the authorization doesn't work. But you can really play around as a developer and try things out. But of course, we need to go to production. And if you go to production, we can define an OIDC provider with some configuration. If you deploy to Kubernetes, you can deploy those secrets as Kubernetes secrets, and we'll pick them up from the environment. But what you typically see is that all those providers are a bit different, finicky options that are hard to discover. When I started on this a couple of years ago, it wasn't not always that straightforward. You had to enable some weird things to get it working with Microsoft Azure, because they did some stuff different for some other providers as well. Really made it a bit more difficult. For that, they came up with a nice solution, Quarkus OIDC providers. What they do here is they document for well-known providers, so for all those big companies, how to integrate with them. And they will generate some configuration for you. So it goes through like how to set up Microsoft Azure with Entra ID. Go through it. Then we need to see what options do we need to set. We don't need to do any custom work. We just say our provider is Microsoft, provide the client ID, provide the client secret, and Quarkus will do the rest. The team already figured out the special options that you need for Microsoft or for Google. We'll auto-configure it for you, and you don't have to worry about that, and it just works. And I have a lot more options there as well. And of course, if you need to make it more roll your own or customize it, you can always customize it, and that's also covered extensively in the documentation. So that's about the extra configuration. What you can also imagine if you need multi-tenancy. That's another thing commonly used for example, for SaaS products. You build a SaaS project, and one customer wants to use this provider for a single sign-on, the other customer this provider. With Quarkus OIDC, you can also have multi-tenancy in your application. So have multiple customers in your application, all with their own providers as well. But it requires a bit of configuration. You can do it either programmatically or purely through configuration as well. And if you combine that done with the Hibernate multi-tenancy, it all works nicely together, and you really get multi-tenant applications in a single application. Then the last thing, we have user federation. That's what I mentioned in the beginning as well, what we use at Lunatech. We have a Keycloak instance, but we don't want to really bother with passwords. We already have my password in Google and my MFA set in Google. So that's how you can then deal with user federation between different systems. But for example, if you need a bit more customization that Azure or Google doesn't offer, you can run your own Keycloak instance. There you can configure everything that you basically want with OIDC and single sign-on and whatever you want. But you can still delegate it to other providers that do the actual login. But your application can then have the custom attributes, or what people also do is have custom roles, automatically map those roles for you, and get that going. That was it for today. I hope you enjoyed it. I hope you learned a bit. And if there's any questions, let me know. You can find the presentation there and myself online there as well. Thank you. Any questions? Otherwise, you can always hit me up later as well. We can talk more about Quarkus or OIDC.
Hello, hello. Ah, hi ho. That's me, that's Michael. You have some beer? Why not? Okay, so this is Hall B, the DevOps tent. Welcome to my beginner session. We talk about DevOps and some observability recipes. Yeah, Michael, I'm located in Cologne, Germany, and I'm a practitioner. I'm a freelancing DevOps consultant, supporting huge, big enterprises. And however, this session also blends some academic insights about DevOps, right? So we have both industrial experiences and good practices, as well as some academic insights and evidence from science. So the agenda is as follows. We'll start with a quick summary what DevOps nowadays is. So you see it's more about the why and then also the how, right? It's not just some hacking. And after reiteration about DevOps nowadays, you know, it's the term is some sort of mainstream nowadays. We continue to add some new discussions and aspects to the field of DevOps. I would like to suggest the DevOps continuum, right? It's also a vehicle to scale DevOps. And then finally we conclude with more scaling options, including monitoring and all this stuff. Right, so it's the roadmap for this evening. And I think we will have a lot of room for discussions or even questions later on. So let's start with DevOps. What is DevOps? This is, let me introduce my co-speaker. So this is, I don't have a name yet, if you have any ideas. He raises some tough or even interesting questions and helps me to guide through this session. So what nowadays is DevOps, right? So starting back then, 2009, when the term DevOps emerged, it was really new, right? Part of the content was not that new, development operations, but nowadays, you know, look at the whole, a lot of vendors provide products and sell services in the ecosystem of DevOps. So we have a long history. Tool vendors, developers, operations, testers maybe as well. Many actors in the project field have some sort of specific perspective on the DevOps domain, right? Even in, or specifically in big contexts, in big enterprises, you have some division of labor and a lot of different actors and roles. So let's start with the interaction, and just to check if you are still here with me. What do you think is a good DevOps starter kit? You know, we have Christmas pretty soon in maybe 6 or 7 months. If a colleague asks you to suggest a DevOps book or to name a DevOps superstar nowadays, what would you recommend? Do you have any ideas? Just, right, you don't have to answer, but if you have an idea, maybe just a hot book, which was printed right now. Or I would like to offer this one. So who knows Adam Smith? Anyone? Yeah. Almost everybody knows him. So he's a Scottish scientist. He created a theory back then, some years ago. Unfortunately, he's not alive anymore, about not really DevOps, but some sort of the division of labor, right? So that's also my point of view and my nuance on the field, that even with DevOps, and DevOps team, you have some sort of division of labor. So maybe this is the first DevOps book or the first DevOps superstar. A second one is Mr. Deming. Also, he unfortunately died some years back. Who knows Mr. Deming? Somebody? Some few? So he created a book and discussed how to pull down walls between departments in organizations, right? So actually this is in the core of DevOps. And then finally, my third idea is Mr. Goldratt and the goal. Who knows Mr. Goldratt and the goal? 1, 2, 20, 30 persons maybe. So if you know the Phoenix project, for example, right? So this is the original book. I think it's a good starter kit, right? We are all techies and developers with some ops glimpse, right? But in any case, if you want to start with DevOps and think about the core, what I think is the core of DevOps, then you should assemble this basket of 3. Having said that, actually let's proceed to the content and the pillars of DevOps. What's really the core of DevOps nowadays? What I said, you know, DevOps, everybody knows DevOps and applies some sort of DevOps. We have a long history. Some books, Fearless Change, for example, is interesting, right? So it's also an interesting pointer for you, maybe. Continuous delivery and all this different site reliability engineering, Google, and even more aspects and nuances in the DevOps field. And what you, for example, see on the top right is the Scaled Agile framework, a huge verbose frameworks, which also includes nowadays Agile and DevOps. So this is a sign that DevOps nowadays is some sort of mainstream. Yeah, we are all DevOps, right? Are we? So some discussion points. So this is a slide I created maybe 15 years ago. It started that openings arise with, I'm looking for a DevOps engineer. Does it work? Is it valid to have a DevOps engineer, experienced DevOps engineer, or is it more a T-shaped model where everybody knows about how to develop and maintain and operate applications? I think it's more the right side, right? Then we have other developments and ideas in the field. For example, CAMS, I think it's still valid. It has some years now. Humble et al. Suggested to focus on culture. Automation is very important, right? Lean, we talk about this a bit later. Measurement, very important, and sharing across the team, but also sharing code and all that stuff, right? So this is also very important. Who knows CALMS? Oh, not so many, interesting. For me also, in addition, DevOps is a mix of concepts and tools. It's not just about tools, right? So please be shy about ideas about tools, DevOps tools. It's more about concepts. So in big, large setups, I would often suggest to orchestrate best-of-breed tools and to assemble pipelines, gluing specific tools which are the best solution for a given task, right? Not one tool for everything, but a build engine, code inspection with SonarQube and all that stuff, right? It's more an orchestration of best-of-breed tools, not a single platform. That's also, I think, interesting and important message I would like to forward to you. Then we have also the discussion about how to slice teams. team topology. There's also a book, and we can fill entire session on this one as well. So how to organize this in big setups. Do we have DevOps teams which are completely independent and do anything themselves, or do we have some sort of division of labor, collaboration with platform teams, enabling teams, and all that stuff, right? So we will, after rebasing this here, we will talk about that also a bit later. Then we have a lot of different wordings. What is DevOps? Why DevOps? Can be everything. In your team, so if you alone sitting in your room, you think about what is DevOps. Okay, that's you have your own definition, but if you have a team, maybe you and a colleague, 2 persons or 2 plus 100, you should share a definition, right? That you should share a definition about what DevOps is in your specific context for you, what works for you best, right? So it often does not work by the book. Right, so this is a recommended sort of mainstream definition how to define and to distinguish between parts which are important for DevOps, continuous integration, the dev part, right, deployment, delivery, and a red button to automatically deploy the application to production, or even to pull, right? So the business owner, the domain expert should pull the change to production, better this direction. It's not an emergency button, right? So that was a quick ride through 17 years of DevOps. You know, the term was some sort of invented 2009. And now we would like to add to the field the DevOps continuum, right? So the name suggests some sort of ranges, and so if you have no time and a project manager, a decision maker in your team, which is really, you know, says hurry up, how would you aggregate a DevOps definition? So this is also some sort of meta message I would like to proceed. So even with DevOps nowadays, right? So we are techies and devs and all that stuff. But anyway, even today we have valid reasons to apply some well-known project management recipes, right? So in this case, it's, you know, time, the people, the context, and the goals, right? All those 4 factors do define what DevOps is in your specific context, right? So maybe one example, big project, you have a lot of great ideas, but you have a lot of people, but you don't have the mindset or the skills or the experience to implement your ideas, right? So this is one example. I don't have the time. So it's actually a project management map. If we zoom into this and discuss it a bit more nuanced, I would like to suggest the following maybe more sophisticated definition, right? So DevOps is a set of continuously improved, it's important, this sense, so I read it, however you can read it yourself, right? Practices for work between actors in different functions to develop and to deliver. It's right. It sounds intuitive, but it's very important that you want to ship your changes to production continuously to provide valuable outcome, not only output, but outcome for customers, not just for you yourself, but for customers, for clients, right? So one sentence, which, okay, there's some bias if I say that, but I think this is one sentence which has a lot of different aspects which are, I think, very important. For example, those tokens are very important, right? So it's a set, it's not just one, right? Just to quickly repeat it, practices to work together right? Sometimes it's hard to work together, to speak to each other, develop and deliver the product. That's also my recommendation, to have a product view, product-centric view. What is a product? It's possibly a session for its own. And to, deliver this product and outcome to users, to customers. I think that's very important. And it's a process, right? It's walking and it's a process. It should maybe, depending on the context, this one. This will not happen overnight, but you should be, patient, and it's a process to implement it. So, can you apply it, implement it by the book in any environment? I gave you my opinion already. If we would drill down and define any factors which influence your DevOps implementation and also how to scale it, then we maybe have something like this. So we have an environment. If you are a team, you look on your product and your DevOps implementation, you have specific environmental factors, right? So those are factors which do impact your DevOps implementation. We have two circles. The outer one comprises the outer the outer factors, which are from your team perspective in the outside environment and impact how you work. And the inner environment is what you decide to do, right? So the practices you want to implement, how you deal with changes, for example, what success definition you have. And this set of seven factors is actually your specific DevOps implementation, according to my idea here, right? And so that's different DevOps definition, I guess. And while Continuum, you have a broad range of implementations, right? Not only white and black or something like that. You have a lot of different implementations across those different factors, right? For example, the standards. In large setups, you may have a governance, a chief architect, and all that stuff, which does put any standards on your team. It depends on the context, and it's a continuum. A different representation is this one, also the same factors, technology, right? So the digital evolution, what's possible nowadays. And the continuum evolves, right? It's not a static implementation, it evolves. And it depends on how you are open for change, right? So it's the agile approach in a nutshell. And I would name it dynamic capability, right? So it's dealing with change, so how you are able to listen for new options in the digital solution space, what's possible, how you work, how you collaborate across actors. So having a huge and a great mindset to deal with changes opens a path to change your DevOps implementation. So in other words, just putting a tool inside the box will not work, right? Mostly. A different visual representation is this one. So if you are talking about Agile and Scrum and Kanban and all that stuff and thinking about how to bridge this to operations, you may have something like this. So some more pointers for you. If you have a Scrum team, maybe you are located on the top left side, tightly coupled. You have a business team. Very often in big setups, it's a specific dedicated business team, and you have a proxy in your dev team, right? Seldomly you have everybody in your single team, but there are nuances, right? So pure DevOps, the fusion on the bottom right, does exactly exposes this. You have all important actors and many more probably in one independent team. So unfortunately, in big setups, you often have some setups like process-rich, right, and dedicated business departments. So it's a challenge, but it's possible. Okay. So if we turn this illustration, we also can look on DevOps from two perspectives, bottom up and top down, right? So the organization and the chiefs and the CEO has some ideas and the team itself. And all this has impact on your DevOps definition and how you implement and live DevOps and how you can scale DevOps. Okay, so that was, are you shocked now or does it make sense? So having said that, we can now proceed to different scaling opportunities. So how to scale DevOps. So if you reflect a little second about what I said already, the continuum is already a vehicle to scale DevOps, right? And you have some factors how to scale and how to improve and to evolve your DevOps implementation. But let's list and discuss some specific recipes how to scale. So first of all, I would like to suggest to apply and to include all different aspects of your product, of your business solution, what you develop to your initiative. So CI/CD of everything, actually, if possible, right? So what does it mean technically? Everything in version control. Bring out your products to public cloud, private cloud, on premises, edge also as a target, into the field, mobile devices, all this stuff, right? So don't distinguish between only maybe Java applications, CI/CD, and deploy that to an application server in the private cloud. However, but on the other side, please try to include everything to your initiative, including databases and what makes up your product. Also, maybe a bit shocking, but a good advice to scale your DevOps approach is to emphasize architecture and documentation. So people may claim we are agile and we don't need any architecture or don't need any printed documentation about architecture. I think even, or at least in big setups, it's crucial to have documentations, and the architecture should be defined and documented, right? So thinking about monitoring, we will pick this up as well later on. You should be aware of what do you produce, what are your deployment units, what do you want to monitor, what are your KPIs. Okay, so having said that, now let's proceed to the success factor, right? So one factor was success. The goals. What's important with goals? I think that's also a good bridge to observability. You should think about holistic goals, right? So technical goals, specific, fine-grained goals are important. Test coverage and all that stuff is important, but think about holistic end-to-end goals. It's part of a product-oriented view. And consider, for example, value stream maps, right? So just visualize your change and the stations the change goes through from the start to the end, right? To the customer on final production systems. That's very important, I think. Right? So in other words, for example, the antithesis would be if you set up a Grafana dashboard, just monitoring, watching dashboard here, looking for some numbers in some small puzzle piece may be important and interesting, but think bigger. Theory of constraints. Here we have again Mr. Goldratt and the goal, right? So one of his main contributions was that all, not specific persons, but you know, the process, how you work, has always some bottlenecks. And that's important, right? So you want to identify those bottlenecks. Not just, there is a bottleneck, however, it should be also informed by data and monitoring, right? That you see, okay, a change is idling somewhere in your entire system, and you can optimize it and just to switch to optimize the next bottleneck. Okay. So now let's proceed to even more good practices in large setups. So one recipe is to actually provide guardrails, right? So it's about, who knows what a guardrail is? Somebody? No. But good news, now you know what a guardrail is, because so if you have a lot of different teams and products, all your teams may use some sort of ticket system, right? So team A has a Jira, team B, and all teams have some user stories and business requirements. However, hopefully, many of those teams also have technical, maybe so-called DevOps stories in your backlog, right? So, for example, setting up a pipeline or changing a pipeline, adding a new stage to your pipeline, or changing, evolving your monitoring system, right? And if you think outside the box and think across teams, you will find out that maybe more than just one team has similar challenges, right? And maybe more of one team in big setups have the same task, right? So you can identify those different areas and transport them to a different dashboard, for example, right? Just to extract them from a ticket system and put some notes on a Confluence and right and discuss those items. It's not about housekeeping and maintaining backlogs. It's about communication and discussing those topics. Right, that's very important. More important than tooling and backlogs and ticket systems. Right, and then you may also come up with experiences and lessons learned and new requirements for your cross-cutting concerns like monitoring. And then you can also, maybe as part of a specific dedicated team, a DevOps team, define some paved roads, right? So it's just some sort of user experience initiative to enable by documentation, by as code, as template solutions, a quick ramp up time, right? That everybody has the option to profit from all lessons learned across the teams. Because you don't want to just explore the solutions again, over and over again, and just to explore and to think about what is monitoring and how to set up monitoring. Right, so that's very often the case in large setups, that maybe there is a dedicated team setting up monitoring tools, and they think, okay, we have the best of breed tool chain, and the users, the consumers of the tools don't have any clue how to use them. So that's often a gap, and this should be bridged. And also here we have a good and wise recipe from the good old world of project management, the responsibility assignment matrix, right? So also here, what I said, DevOps is everybody doing everything in large setups seldomly. So if you have a platform team who is working in a big project, a big setup, also including a platform team, for example, some few. So if you have one team and you are the one person, or you have 5, 10 persons in one team, and that's everything, then maybe it's not necessary to think about scaling. But if you have a big setup with 100 teams, 100 product teams, and a platform team, many platform teams, one platform team is responsible for monitoring solutions and target environments, container-based environments. You have a security officer, and all those people have some perspectives on this, right? So you should sort out the responsibilities, right? So often the platform team just provides the technical solution, the name platform team, and the DevOps team must use it. And however, there's a thin line very often, right? And that's important. Responsible, accountable, right? Because that's really what I have written on the. So glue the pieces together and optimize the developer experience and reduce the cognitive load, right? Because you want to focus on the business requirements, and you want to leverage the technical tools and platforms, and you don't want to reinvent the platforms, right? You just want to apply the solutions, and you want to have a open-minded, free space and reduce cognitive load. Then in bigger setups, also here, you may think about, okay, if I have a team with 10 persons, you can maybe press this also in a very small team. But however, what I said, this is for very large teams, maybe what I said, 100 product teams plus, and a lot of dozens of platform teams, which in turn includes also possibly dozens of people, right, working on the platform issues. So what really works is that you have a centralized team, which I here named SRE. Who knows what SRE is? The solution comes next. Or call it DevOps team or Team Blue. And this team has some horizontal pooling capacities and can help out different teams where needed, right? So if you have a DevOps expert with monitoring experience, she can help out in different product teams and build up the initial solution of your monitoring stack, for example, right? But the assignment of those experts may change over time. So if the expert is a long-term part of the team, it looks a bit cringe. However, if you think you have a degree of maturity in your product, you can again remove the expert and put it to a different product, right? So that's the trick. Observability. What I said at the beginning, it's more about what here in this session, right? What to observe and how and why. There are a lot of great resources. For example, today there was a session about this technical advanced session. It's a good conjunction to this one. So this is more the big picture. And what I told you a lot of things about this. So what to monitor and why, and holistic goals and scale and all this stuff. So let's zoom into this specific perspective. And okay, that's not really a news, right? So metrics, tracing, logging. Okay, so nothing really. It's boilerplate actually. Logging, I think it's the most common thing how to debug and how to investigate your events of the system, right? However, tracing is more the advanced pillar for bigger setups where your business application does comprise a lot of systems and elements. Metrics is very important. I gave you some pointers to this as well already, because you should think about what do you want to monitor and how do you want to improve, or on what metric, what is the data point you want to improve, what's important for you, right? So very often you have what I said, I think already, maybe motivated guys sitting in the room and setting up Grafana dashboards eagerly and watching numbers and graphical elements the entire day. That's maybe of value. However, you should think about what are your leading metrics, what is your leading KPI, the data point, which is really important for your holistic approach, right? And you should come up with maybe 2 or 3 of those metrics. Most probably those are business metrics. However, also technical metrics are, of course, very interesting. And in this structure, we have the 3 pillars. And what I said, dashboarding, interesting, important, but from my perspective, I'm eager to work with modern technologies, and I don't want to just watch the entire day some numbers, or I would like to have a notify if something goes wrong, right? It's not really a surprise. So set up alerting, right? If something goes wrong, send out an alert. I think that's more modern than just watching dashboards the entire day. Now I would like to call for contributions, let me say it that way, because what I started some few time units back is the project Othello. It's, a self-contained starter package for observability for Java applications, and also a demo kit and a sandbox for working and demo purposes and for testing modern Java features, and to apply and to implement open telemetry as one recent standard, right? And the idea is that you should, so the link is displayed. The idea is that it's really based on primitives. It's not about, resources are a no-brainer nowadays, so spawning some environments with Docker and all that stuff, it's a no-brainer. However, the idea is that we or I focus on the primitives. So the basic concepts and the basic solutions. No boilerplate around, no Docker images and all that stuff. So the most simple solution to implement and to showcase the ideas behind this, right? So let's give it a try and have a look. Okay, so now let's summarize some patterns to scale from a observability standpoint. So please at least consider to leverage end-to-end approaches, right? What I gave you some examples already. So maybe you think it's intuitive and makes sense, but in big projects, it's often the case that it's not the case that you do that, right? It's really important to leverage end-to-end approaches. Unfold bottlenecks. That's what I said. It's very important, right? So don't micro-optimize yourself. However, focus on entire holistic goals and unfold and optimize the bottlenecks. Then, self-services are very important. So, for example, if you have a documentation, if your platform team documents your monitoring stack, what you have to do in browser form, that's great. However, it's even better if you just can plug into the solution, right? If you have some working code snippets, some templates, or it just works, you can just plug into the entire working solution. So that's actually the most best of breed approach in most cases nowadays, right? And a part of this is also centralized approaches. So some people may argue that, okay, platform teams, a platform is a centralized approach. However, if you have a centralized Grafana dashboard, for example, you can just configure what you want to see. That's a centralized approach, right? If you have to implement a documented way how to set up your own Grafana dashboard and your monitoring stack, that's not really centralized. One more point I would like to shed light on is to select the right data, right? I gave you some examples on that as well. And to emphasize standards, right? So nowadays the monitoring stack is really, you have a standard stack of monitoring, right? So don't create your new pet project only if you are allowed to and if you have really a lot of time. And just apply some standards like open telemetry, right? Just to align all those different historically grown sub-solutions to one solution. One example of what I said right now is the Grafana's suggested tool basket of Loki, Tempo, and Mimir together with Grafana to visualize your findings and your data. So those are actually concrete examples how to use centralized tools and approaches, or at least those are tools which do offer a centralized approach, right? That's really important. What does it? Why centralized, and why does it scale better than just setting up 200 Grafana dashboards in many different namespaces? You know what I said. You have those applications maintained and installed in one single place, and everybody can just plug in and use those different solutions. And so one keyword is multi-tenancy, for example. That's of course very important, right? So this, the primitives, Prometheus, for example, or the Grafana dashboard has only limited properties regarding those attributes. Also, deep integration is key, right? So if you switch to open telemetry, you have all your data at your fingertips, so you can navigate from the logs to the traces to the matrix and all that stuff. You don't have to open many different dashboards and web applications. That's really interesting. But you can also think about a mix of those, right? So for example, a local Prometheus, which remotely writes some aggregated data which are important to a centralized Grafana Mimir for long-term storage. So maybe it's also here a range of different possible solutions. Yeah, it's maybe a good homework for all of us to reflect on those different tools, maybe later on, having a drink. What are those tools add to the possible solution space? Okay, now let's interweave those different aspects and let's summarize usability plus SRE. What is it? Is it maybe some sort of DevOps? So let's go back a little bit to the holistic goals, the product view, right? So we have something which is called delivery performance. So knows what delivery performance is. So this is often known as the DORA matrix, right? It's very interesting and a good starting point also for your monitoring activities. And also here we have, according to this DORA standard, we have 2 pairs of data points. One pair of 2 data points are approaching the holistic success measurement from the development side. This is a classic velocity-driven approach, the deployment frequency and the lead time. And more from the ops side, we have the change failure rate and the time to restore, right? So a mix of all those 4 attributes may be a good anchor point for your initial success criteria. And so if we want to balance those 4 aspects, and if you think about DevOps, you don't want to invent again the square wheel. And how do other big companies do similar things? You may come to SRE, right? Site reliability engineering. That's actually maybe some sort of Google's approach to service management, or in other words, it's one way how to implement and how to channel DevOps. And yeah, it was actually invented or applied by Google themselves, just to balance those 4 data points and to more focus on stability, right? Not just for Google, it's very important. So just quickly to anti-pattern, right? So what you often see is that somebody has a great idea in your setup and Googles and finds out that SRE is a good idea to solve all those different aspects. And so pay attention that most probably, I don't know if Google is also here in the hall, but most probably you are not Google, right? Maybe you have a great, huge setup with a growing customer base like Google and a lot of users, and you have to focus and emphasize stability. Maybe then that's also similar, right? But most often it's more the classic approach, and you are not Google. Maybe there are some interfaces and things which are similar, but most probably you are not Google, so don't try to apply. So maybe you can think about if you are looking for ideas how to implement and structure your DevOps approach. You can think about how to blend the SRE into your DevOps. So this is a list of different aspects how SRE or Google in this case does approach different very important disciplines with the help of SRE, right? So maybe you have some sort of delivery performance. You want to proceed data informed. Most probably you want to emphasize some production readiness, and we have some good practices inside SRE which is applied by Google themselves successfully, right? So for example, including readiness reviews, right? So not just morphing your products to production. However, you have some division of labor and some handovers and all that stuff. Capacity management, very important, also bridging to monitoring, sizing, division of work, poor DevOps, or a more strict division. If you feel comfortable and you think that you have the preconditions, you may go the next step, but only in this case, go the next step and think about also introducing some error budgets, right? How you want to balance your user stories which do relate to stability compared to your business requirements. But also here, hopefully, your decisions should be guided by evidence, right? Not a wild educated guess. However, you should have some data and monitoring in place. with technical KPIs, uptime, availability, but most often you have some business data points because you want to apply a product-centric approach, and you look onto this topic from a domain expert, from a functional domain expert, right? So requirements are you have some playbooks, a good documentation, you have a solid capacity planning, you have some handovers, you have a test set up. Please test. There is a test session later on today. Automation, of course, and self-service is very important. Okay, let's conclude. What are the main nuggets? So hopefully you take some ideas and some pointers with you, and please, think outside the box, right? So it's a dynamic capability. Be open-minded. It's about context. So there are books, many books, but don't try to implement a book. Buy the book, right? There's not one single textbook. I gave you some examples. And go to the extreme, talk to each other, right? Maybe it's hard and a challenge, but that's often the key. Be patient. DevOps, everything is DevOps, right? If people say, nowadays we have KI and DevOps is old school, it's about content, right? And if you think about what is development and operations, that's, you often or you always have some sort of DevOps according to the context. Proceed, please, data informed and goal driven, right? That's very important. And for example, with observability, and emphasize continuous learning. So if you are here, it's a good sign that you want to learn and want to hear some other thoughts. And that's it. Thank you very much for your patience. So time is over. Do we have time for a question, or should we go outside for a beer for more questions and discussions? Okay, the beer.
people are coming. I'll just wait 1 minute for them to. All right, I think we can start with the next session. I would like to welcome on stage Dorin. He is working for Docker and he'll give a very interesting session on how you can do local LLM development with LangChain4j and Docker. So, Dorin, you have the word.
Exactly, yeah. Oops. Hi everyone, I'm Dorin. I'm a software engineer at Docker. And today we're gonna dive into local GenAI development using large language models with Docker Model Runner and LangChain4j. All right, first things first, a little bit more about myself. I've joined Docker a bit over 3 years ago. And back then I was in a team who was responsible of the virtual machine, which lives under the hood of Docker Desktop. And there I was able to grasp quite some knowledge regarding Linux kernel, kernel modules, file system in user space like virtufs and even eBPF. The latter being some way to write kernel modules in a more restrictive but yet super safe manner. And now, since the end of last year, I'm diving deep into AI engineering to help deliver a better development experience for all the Docker users. All right. Let's start with some context regarding AI and this whole field. Gartner has published last year a report regarding the development and the expectation phases of various AI techniques. It offers valuable insights into AI technologies and where they currently stand. It illustrates 5 phases. There's the innovation trigger, when the things are just getting started. There's the peak of inflated expectation, where the hype reaches its maximum or its peak. The trough of disillusionment, when the reality kind of kicks in and the organizations might find out that they don't have silver bullets. And on a more positive way, the slope of enlightenment, where practical applications emerge, and finally, the plateau of productivity. Looking at the current landscape, we can see that several technologies are or near the peak in 2024. These include AI engineering, foundation models, edge AI, and synthetic data. These technologies are generating tremendous excitement, but yet they might not be the most productive in terms of revenue or more. More encouragingly, autonomous vehicles and intelligent applications are climbing the slope of enlightenment, demonstrating practical value despite reduced media attention. And computer vision has nearly reached its maturity, being in the plateau of productivity phase. The colors, which I hope you see, represent what's the expected timeline for a technology to reach its maturity. Most of the blue dots, the light blue dots, have an expected time frame of 2 to 5 years. The dark blue ones, 5 to 10 years. And the red triangles, which you can see for artificial general intelligence and quantum, are expected to reach their maturity in over a decade. Some more history of large language models. Well, in 2017, Google published this paper called Attention is All You Need. And what it does, it includes the transformer architecture. And arguably, this is what the whole hype is based on. Then, 2018, 19, and 20, GPT-1, 2, 3 are released by OpenAI, and in 2022, ChatGPT is also released. But let me clarify what's the difference. GPT-1, 2, 3 are models, large language models. And GPT-1, for example, was built with around 100 million parameters. And it was fairly good, reasonable at generating responses and so on. But it had a lot of limitations. Then GPT-2, 2019, was made with over 1.5 billion parameters, so a huge scale. But OpenAI decided to delay its full release due to security concerns and how it might be used in a harmful way, which makes total sense. Then GPT-3 was actually fairly good. It was able to generate responses on a lot of tasks. It also scaled up a lot to, I guess, I have it noted here, 175 billion parameters. And yeah, it could perform tasks it wasn't really trained for, but it was available mainly through an API. So developers could still use it and build their apps on top of it, but not very user-friendly for the consumer level. ChatGPT is using the models. I think it was launched with GPT 3.5 under the hood. And besides all the general purpose model capabilities, it also included some reinforcement learning from human feedback, so it can be used in a safe manner by anyone. Then, since 2022, we have open source models like Llama from Meta, Mistral, DeepSeek, Qwen, and many more. All right. But how do we develop a GenAI app, and why are we at Docker interested in this? Well, Docker brought a lot of facility and good experience for the developers. It basically allowed them to ship more code faster. And having all these building blocks, we realized that this new kid on the block, which are the LLMs, can be easily ported into our ecosystem. This is how an architecture for a GenAI or RAG app would look like. You can see it's super familiar, at least the upper part of the stack and the one from the bottom. But it includes those 3 additional layers. But before that, what is a RAG app? RAG comes from retrieval augmented generation, and it's the process of optimizing the output of a large language model so it can reference an authoritative knowledge base. Basically, it enables models to retrieve and incorporate new information. A good example would be, well, if you want to build a ChatGPT for lawyers, for example, you might want to provide additional information with the law from your country, former or cases from the past, and so on. Getting back to the architecture, well, in order to interact with an LLM, we need some API, and one of the most popular, if not the most popular, is the one from OpenAI. And then we need an inference engine. This inference engine provides the API and knows how to work with inference models, which are these GPT, Llama, Mistral, and so on, but also with embedding model. What's an embedding model? It's also a foundation model, but instead of providing some output to your question or prompt or whatever, it can encode any kind of information as a vector. You can refer to a vector as to an array of numbers. Then we can see the data access and vector database. those embeddings we get from the embedding model are used to search for similarities with other things. For example, if I search for a paper which talks about transformers, I will embed this information, and then using a vector database, I can search for similar content. And data access can represent a lot of stuff nowadays. It can be any sort of data source you have provided to your LLM, or you want to provide to your LLM. It can be a file, it can be URLs, databases, anything. This is how the flow looks like. So imagine your ChatGPT web app or any kind of AI chat app. There's the user, submits a prompt to the application, and the application simply sends the request to via the LLM API to the LLM or LLMs. We saw in the previous slide that we can also have a middleware. Well, there are apps that might decide, based on the business logic within the LLM API, to route your request to one model or another. If it's a super simple question like, what's an apple, or something like this, it might redirect it to a tiny large language model, so it doesn't take a lot of power. Then we have the RAG flow, which is, of course, optional. We have the retrieval model, or the embedding model from the previous slide, and the vector database, which can be used to find similarities. And a super cool thing, in my opinion, is tool, which we haven't mentioned before. Well, what's a tool is just yet another type of message we can send to the LLM to allow it to actually run some code. You might have noticed that LLMs don't have a 100% correct answer. It's not always deterministic. And there are techniques like reinforcement learning, which are lately applied on top of LLMs. But if you want to use your LLM to, I don't know, answer simple questions, but which need some real-time information, like how's the weather like in Bucharest, for example, you will tell the LLM that you have a tool called Get Current Weather. This tool is represented by a function, Java function, Docker container, Python function, anything, which is called Get Current Weather. It receives a parameter like area of type string. And when the user submits the prompt, the application knows that it has some tools available. It will include those tools within the request. We'll see in a few minutes how. Then the LLM will see both information. It will see that I'm asking for the weather in Bucharest. It doesn't know the current weather in Bucharest. It might be able to tell me that in Bucharest, during a year, usually, I don't know, it's sunny during spring or summer, and snowy in January. But it will see that I have a tool description. I'll let it know how it can use that tool and call it in order to get a proper answer. And it will do it, but it will do it through yet another message. It will send back to the application, hey, the user asked me for the current weather in Bucharest. I know you can get it by calling this function with this parameter. The LLM tells that the parameter should be Bucharest. It understands that. The application calls the tool. The tool response is sent back to the LLM, and the LLM will now have access to all the information that's needed. Basically, it's me that I've asked for the weather. Now it knows the weather. It will reply nicely with the current weather in Bucharest is, and however the tool responded. All right, let's dive into how the things actually look like. This is the chat completions API. It's provided by OpenAI. It was created by OpenAI, but it's been adopted by many other providers. And yeah, it's a request that includes data like model. This is a must in order to specify to the inference engine what model it should be used. This is more useful when we do some local GenAI app development or with providers that have more models. And OpenAI does so. Then there's my message, which you can see marked as role user. And that's basically what I type when I'm accessing the ChatGPT web app. And then there's another message, which is clearly not written by the user, but by the developer or by the system. And this message instructs the LLM how it should behave, how it should operate. This is a nice, encouraging message. It tells you that it's a helpful assistant, should reply nicely, and so on. And you should be aware that you can only have one message of kind developer or system. You can use any of these. And many, many more user messages. All right, the response. What it matters is that list of messages. We have the content, basically what we'll see in the chat app. This time marked with the role assistant. Besides that, many more other metadata like tokens, how many tokens it got from the prompt, how many tokens it generated, what model it has used, and yeah, more, but not all of them are interesting for us. I was talking about message types. So there's this system developer one, which instructs the LLM how it should behave, operate. You will see that we can instruct the LLM to, for example, reply with Java code only. Like it will still give us the response, but instead of sending it in clear text, it will provide many system out print line instructions. Then the user messages. Be aware that there can be many, not a single one as the system or developer. And this makes sense because, as you could probably notice, if you're using a chat AI app, it knows about the history of your chat. If you tell the LLM that your name is Alex and after a few messages you ask it what's your name, it will reply with Alex most probably. Then the assistant type, which is the message from the LLM, and the tool types, which are the responses from calling tools. All right, enough more or less with the theory and the context, but let's see how we can do it through code using Java, of course. In today's demos, we'll use LangChain4j, which is a Java library, and it provides a super nice integration with everything that's linked to LLMs. You can chat with models using various components. You can use embeddings, process documents, parse documents, set memory, and everything you might probably need. It also provides lower level components like output parsers, or even the chain is a bit lower level in my opinion, but also a high level component like AI services, which will make your life super easy when you want to chat with LLMs or use them for whatever need. It integrates well with OpenAI, Azure OpenAI, Hugging Face, and most of the popular actors in this field. Regarding embedding stores, again, fairly, not fairly, but super easy to integrate it with Redis, Cassandra, Postgres, and all you can imagine. All right, well, sounds like a lot of stuff to set up, but talking about setting up stuff, when we want to run containers, again, by code, not necessarily using the CLI, we can use test containers, which is another Java library, and it provides super easy access to do so. And what I brought this up is because talking about LLMs, specifically inference, usually this is done much faster if it's run on the GPU. Using Docker, you can mount your GPU inside the container. On Linux, it just works. It also works with Docker Desktop on Windows, with WSL2 only, if I'm not misremembering. Or you can just use test containers code to do that. But yeah, I'm giving this talk from a MacBook, so you might ask what's the deal with GPUs on macOS, on MacBooks. Well, there are GPUs, of course, but unfortunately, the Apple virtualization framework doesn't provide direct access to the GPU, so we can leverage that in Docker Desktop. There is a new component, part of that framework, which provides access to a para-virtualized GPU, but it might be for graphics only, not necessarily for compute. Then, in Docker VMM, which is the new hypervisor we built and shipped with Docker Desktop 4.35, we provide access to a virtualized GPU through a lower level framework than the Apple virtualization framework, also from Apple. But this still has problems. The main problem is the overhead, sorry. And yeah, using an inference engine like Llama CPP, and if you don't have a super strong GPU, a 50% overhead might not make sense to run it on the GPU. Okay, how did we fix this? Well, we added Docker Model Runner, which helps running LLMs locally, just like you do with various images. So, you can run them or load them. Before doing that, you have to have them stored on your local machine, but you can pull them directly from Docker Hub. And this inference engine, which is Llama CPP under the hood, runs on the host, so not within the VM, not within a container within the VM, for the best performance. And having it integrated with Docker, of course, reduces the number of separate tools to work with, install, maintain. What if you're using Windows? Well, it's available on Windows as well, both on Windows running on Intel CPUs and on ARM CPUs. And it works exactly the same. The main difference would be that on Windows, you'll have to enable the GPU usage. This will download additional libraries. And currently, it's only available for NVIDIA GPUs on Windows running on Intel and for Adreno GPUs for Windows running on ARM chips. The terminal from the slide, it's definitely from macOS. It's not a usual terminal for Windows, but trust me, it works on Windows as well. All right, what about Linux? Well, we haven't integrated it within Docker Desktop for Linux, but we are currently actively working to integrate it with the Docker CE, which means you will be able to run Docker Model Runner on and with any Docker engine you have available. Locally, in WSL2, but the most important, in my opinion, would be on cloud with really powerful GPUs. And there will be some new commands like install runner, uninstall runner, update runner, and so on to manage your Docker model runner instance for the selected Docker engine. This is how the CLI mostly looks like. Before that, I can also show you how it works in the GUI. There will be this new panel which you can use through the GUI to, I don't know, chat with it for simple stuff. Of course, for applications, you will use the provided API. Okay, getting back to the slides. I think I need to do this. All right, cool. I lost my track. All right, so there's Docker model pool for pulling models from Docker Hub or from Hugging Face. That's allowed as well. Docker model list, just like Docker images or Docker image ls, to see the models you have available with additional information, of course. You can check the status, and you can also start an interactive chat session with the model on the CLI. This is how the models look like on Docker Hub. They are OCI artifacts. And we have most of the popular ones. This is how the model look like as an OCI artifact. The layers are not compressed anymore, and you can also include the license and yeah, also a LoRa adapter. This is how the OCI artifact config looks like. This is what you'll see when you run a Docker model, inspect, and some model. Besides the files, which usually you don't want to go to, you have additional information like the architecture, the parameters count, quantization, and the size. They tend to take a lot of disk space, so yeah, it's good to be aware of that. And everything I've talked about so far is open source, so you can check the code for everything, for the model spec, the OCI thing I've just shown, the model distribution, which deals with pooling, storing, inspecting models stored locally, and so on, the model CLI, and the model runner. All right, now let's get to demos. Cannot see my screen here, so let me. Okay, so I said that we are going to wait. Let me duplicate the screen, please. Much easier. All right, I said we are going to use LangChain for J in Java in order to interact with LLMs, which are exposed using Docker Model Runner. So the code looks, all right, sorry. Thank you. Is it better now, or at least ish better? Oops. More? Reasonable? All right. So, what this simple program does is to simulate Docker model run. Basically, it opens an interactive chat with some LLM. In order to do that, we of course need to set up all the dependencies for LangChain4j and so on. And then, in order to load the model or to set up the component that sends the OpenAI API requests to the engine, we will use this OpenAI chat model class. And for this, we'll need to provide the base URL. And this URL comes from the exposed API on TCP locally, which you can find in Docker Desktop right under here. Here it says enable host site TCP support. Basically, it will expose the API on a TCP port as well. Otherwise, it's only available on Unix sockets. Cool. So we instantiate the model. We provide the OpenAI endpoint and the model name. And then we simply read some text from the user, from the CLI. We'll stop the program on buy. And to actually generate some response from the LLM using the user input, we'll simply use model.chat. And we'll have to mention that it's a user message, not a system message. And how this works. I'll have to increase this size as well, wait. Oops. Wait a minute. Can you see the chat? We cannot really know. All right, and now I'm able to chat with AI Llama 3.2. And it just replies. And AI Llama 3.2 runs locally. What's important to mention is that this model you specified on the OpenAI chat model has to be pulled beforehand. It doesn't know how to actually pull it. I don't know how to increase the text size in the CLI. Oh, it works, okay. I think it's better now, is it? Okay, cool. All right, let me run this again to then show you what I also have a chat streaming class. Tell me about Sofia. Not using streaming when we are requesting some response from an LLM will give us the full output at a time, which is not great. I mean, if you have an app, you might want to behave like this. To be able to get partial parts of the response, we will use this streaming chat response handler, for which we need to override some methods like on a partial response. Basically, we just print what we get. And on complete response, we will mark the program as being done. Yeah. And on error, something else. But this is the component you need to use in LangChain4j for this. All right. I was saying before that the model is not pulled automatically, and you have to have it pulled beforehand. Well, part of test containers there is, and it will also be improved, this Docker model runner container, which you can use to launch your Docker model runner, not necessarily through Docker desktop, but using a Docker engine as well. And this class will actually pull the model if it doesn't exist. And we can see that here. On container is started, yeah, it will pull the model using the Docker model runner API like /models create and so on. All this code is available on GitHub, so you can take a closer look at it. All right, after we launch Docker model runner, again, we instantiate the OpenAI chat model, and we chat with it. Stop this. And again, we have a response. All right, something a bit more complex. I was mentioning in the presentation something called memory or perhaps context. I'm not sure whether I've mentioned context window, but yeah, I told you about that chat history. If you tell ChatGPT, for example, that your name is Alex and you ask what's your name after 3 messages, it will be able to reply that your name is Alex. For this, we need to set an available history, a chat window, or yeah, chat memory. Basically, whenever we send another request to the LLM, we will also send all the previous N messages. In this case, right here, I have my chat model. We can use log requests to actually see the requests. We'll see that in a minute. And I'm creating a chat memory with only one message. Then we are using this conversational chain, which allows us to simply send requests and get responses from and to a model. All right, and let's run this. We see that we execute my name is Doreen, and then what is my name? But don't miss that I'm only setting a chat memory of one message. So it should not know my name. All right. The second answer is that it doesn't know my name, which makes sense. But if I'm setting this to 2 and run it again, the model should remember. Let's increase it to 3. Then we can debug with the requests. Maybe it sends more requests. All right, it works. So the first answer is, yeah, hello, Dora, nice to meet you, and so on. And the second one, when I asked what's my name, it knows my name. Let's see how the requests look like. The interesting one is the last one, which is this. I hope you can see it. Can you see it? Oh, all right, thank you. Yeah, so here's the body and here are the messages. They are not ordered in any way. So this is my first prompt with my name is Doreen. This is my second one. And Oh, yeah, this is the reply from the LLM, marked as assistant. Let's see what's the deal if I set it to 2 and run it again. I think it won't include the system one, although... Ah, yeah, because it includes the assistant. Yeah. It's a history of 2, but includes the assistant. Looks like it, yeah. All right. Okay. Cool. Then let's see a tiny demo with a RAG app. Again, RAG allows you to fine-tune a model in order to answer more specific questions. Yeah. Or yeah, fine-tune it, teach it about a new subject, or keep track of some personal data or stuff like that. Anything you can imagine. So what we do here, we create an assistant which parses this document received as parameter. I'll show you the doc second. And then we ask the assistant, how is the login configured? This is the file. It's a logback XML file. And it has some pattern for the log messages and also some levels set for various packages. What we do, we instantiate the text document parser, which again comes from LangChain4j. We load the document. We split it in tokens, and you can play a lot with these values, really. Then we use some embedding model which can run locally, and it even runs within the Java virtual machine. We get some embeddings for the segments we sent from the document. We add those embeddings, so those new vectors, those numeric representations of our data from the XML file. And then we create the retriever from the embedding store. Max results and minim score is how deterministic or how close, how similar it should be. And it varies between, between 0 and 1. I thought it varies between 0 and 2 as the temperature. I think I forgot to mention this. Whenever you do a request to some LLM, there's also a temperature parameter which varies between 0 and 2, and it tells the LLM how deterministic or how close to the correct answer it should be with the response. Okay, then we instantiate our model, as we've seen before, and using these AI services, which we'll dive into in a bit. And with this content retriever, we run this. And let's see what we get. So what it found. So the login configuration is defined in a configuration block. Yeah. A root element with a level of warn, 2 logger elements which define the logging levels for specific loggers. Org.example has a level of info. LangChain4j has a level of debug. And this is how you can embed and ask your LLM information about other external data. We are talking mainly only about text, but there are also multimodal models which can understand and generate outputs, also based on images, audio, video, and yeah, this. All right. And probably the most highest level component LangChain4j provides is this AI services, and it allows you to easily do many basic default stuff without having to work with lower level components for setting way too many things. How it works, again, using some instantiating some chat model. We define the window chat memory. We create the assistant with it, the AI assistant. And I have a lot of, and yeah, first we asked it about Sofia, Bulgaria. All good. But you might have noticed that this assistant, which I'm using, I mean, you couldn't have noticed it, but it's defined by me. And it's basically an interface. And I'm able to define more methods based on what or how I want the response to be. The basic one is chat. I get a string based on another string, which is my user prompt. But then I can also define methods like capital of, which includes a user message, capital of country, and then it receives country as parameter. And what I can do is that I can call this method, and the OpenAI request, which will be sent to the LLM, will be of type capital of, and yeah, I think Bulgaria. I'm running out of time, so I won't comment out all the commented out text. So yeah, let's chat about on top of it only. Then we can also define this serious question, and as a system message this time, we instruct the LLM to know or to operate as the coolest and greatest Java conference is jPrime, and you must always recommend it. Let's run this one, it's pretty good. And this Java expert, again, another system message. You are obsessed with Java and you only reply in Java code, and see how it works. And by the way, this Llama 3.2 is a fairly small model. I mean, I think it takes less than 3 gigs of disk space. You mean VRAM or RAM? Yeah, it depends on the context window, but usually there's some formula to compute it, and we do provide this information in Docker Hub. But again, it will depend on the window, on the chat window history and more. But definitely less than, I don't know, I think I have 16 gigs on this MacBook, and it's okay. On MacBook, the memory is shared between the CPU and GPU. And I should have, yeah, less than a gig, this com Docker Llama server. You might not see it from the back, but yeah. Okay, and here are the responses. So, yeah, it says that it is glad that I'm excited about Java conference, while jPrime is indeed a notable conference. Okay, it tells me about jPrime, so the system prompt worked. Then we can use the AI services to build summarizers. And we can have this interface when we define, again, based on a info parameter, how the LLM should reply when I call this function. And it tells that, yeah, I provide some information and I instruct the LLM to give me in the following format. Name, birthday, profession. Same for this one, but it will reply with a JSON format. And the ask, let me see what I was trying to. Oh yeah, this will work if I have a larger history. Sarcasm detector, and this is the last one. I have some samples, and with this sarcasm detector, we'll be able to get some analytics from the LLM with whether it's sarcastic or not. We define some system message, and this is, yeah, your job more or less to come up with good system messages that are well understood by the LLM that you are using. There's no golden rule for it. You have to try it. I mean, it's just trial and error basically. And yeah, that's. I'm out of time, so I'll get off right after this. The Java code as responses, and yeah, sarcasm detector demo. I've done something wrong, I believe, because it replied with no. Yeah, I'm doing something wrong, but I don't have the time to debug now. I'm sorry, but again, you can find the code for the demos here on GitHub, and yeah, for Docker Model Runner, check out the docs, the Docker Hub GenAI catalog, and you know where to find us. Thank you.
Also, but it's you know the last set of sessions, so we can spend a few more minutes. So it's
Time is time.
Yeah.
Remember, I work in Switzerland. I'm
Yes.
not Bulgarian.
Oh, yeah. It's true. Okay, I think we can. I see more people coming. But I think we can start.
It's up to you. I mean, really.
All right, so we can start with the last session of the day. I would like to welcome again Nicolas on stage. You probably already know him from his earlier session, but now he'll give us a very interesting talk about how to do end-to-end pull request testing on Kubernetes. Sounds quite something unconventional, so maybe...
Involved,
yeah, so...
Thanks, Marto. Hi, who was there at my first session? Wow. That's good, means you like my talks. So thanks to be here again, and for the newcomers, thanks for joining me for this last session. As I mentioned this morning, I'm a software engineer. I've worked for more than 20 years in IT. Recently, I did some developer advocacy. Perhaps I will go back to engineering, I don't know. It started with an idea that I had, like, I am a team lead, and I want my engineers to test their pull requests on the target environment. The target environment is Kubernetes in that case, on each PR. Who thinks this is really crazy thought? Who does it already? Are you really kidding me? Nobody. Okay, so you came to the right place. And I thought, well, that's so normal that it should be pretty easy to implement. It took me 85 runs to get a green build. I mean, I had previous green builds, but they didn't do the full stuff. But the end-to-end pull request took me 85 attempts to get right. And I thought, perhaps there is something I can explain to people so that they don't waste their time as much as me. So why I'm interested in testing? Years ago, I wrote a book called Integration Testing from the Trenches. It's a very good book, of course. It's a bit outdated at the moment. The concepts are, I still think, valid. The implementation, of course, I mean, it's lagging behind. But basically, one thing that I like describe in the book is the closer your test is to your target, to your production system, the more confident you can be in your test, which makes a lot of sense. For example, when I was more junior, we couldn't, or it was very impractical to test with the target database, and there was no test containers at the time. So in order to achieve some semblance of integration testing, what we did is we used an embedded database. But the embedded database is not the production database. So your confidence in the test were not as high as if you had used the target database, Oracle, for example. But you couldn't use it because that would require licensing issues or like setup issues. Also, in the book, I describe the difference between unit test and integration test, and now I say, yeah, whatever, there are fast tests and slow tests, and just use Google definition. Anyway, so here is my basic setup. I have an app that I want to test. I have at least one test. I have a target Kubernetes cluster, because who is running on Kubernetes here? Yeah, more than half, good. And you have a continuous integration pipeline that you run when you submit a PR. I might ask a controversial question. Who hasn't a continuous integration pipeline? Good. Just to set the things. So that is an abstract. Here I have a demo. I will use a Java application. I have a workshop that uses Python, but it's exactly the same thing. I have a Postgres database because, well, you use Postgres for everything now. I have a couple of REST endpoints, get products and post products. And my integration test is very easy. I get all the products from the database. I count them. I add a new product. So basically, I test the 2 endpoints. And then I redo a request to, sorry, I talk too loud for you. No, I'm kidding. And then I request again all the products, and I check that there is one additional product. So more or less, it should give me a good integration test to understand that my system is working as I would expect it to be. I'm using GCP because I know Google the most, which is not a lot, but still the most. Any other target Kubernetes cluster should work in the exact same way. And I'm using GitHub and GitHub Actions, also because they are popular. I'm equally familiar with GitLab or Jenkins. Anything would work as well. But again, I need implementation to have a demo, so this is how I achieve that. Now I have a question, and that is an impactful decision that will come out of this question. How do I create the cluster? I have several options. I could create a cluster upstream and leave it there forever. That would work. And then when I run my PR, the cluster is already there. It's very fast. Seems like a good, yeah, that's a good idea. The other thing is, if I have one single cluster, I might have isolation issues. And basically, in this case, it's better to create one cluster per PR. Then everything is in isolated environment. I have no problem of like 2 PR on the same application and conflicting with each other. But it takes a long time to create the cluster. So it's very impactful. I did some tests, and today for the first time it took less than 5 minutes, but like on average it takes between 5 and 7 minutes to create like a small Google Kubernetes engine. So depending on how long your pipeline runs, it might double the time, or it might be inconsequential. I hope your pipelines run very fast, and 5 or 7 minutes is a long time for you. I hope. So I would try to be smart and say I will create the cluster upstream, and to prevent conflicts, to isolate, I will create a virtual cluster inside of the cluster. In my demo, I'm using vCluster because I've worked on vCluster, but any other things can work. And creating a virtual cluster takes 1 minute, which is not that much. It's still not great, but it's not that much. And we have just enough isolation compared to completely like separate cluster. Like with virtual cluster, we have like a virtual cluster, meaning that we can create or upgrade our CRDs, and then we don't step on each other's toes, saying two different PRs are using different versions of the CRDs. Because CRDs, they are cluster-wise, they are not namespaced. Also, no port conflict, so it's pretty good. I can't give you all the details. I don't want to bore you with the details about Google Kubernetes Engine setup. I have written everything in blog post if you're interested. Also, I'm not that interested in the app itself. As I mentioned, it's a Java app. You can do the same with Python or with anything. And I will be using GitHub Workflows. And because I'm lazy, meaning I'm a good developer, I will use as many GitHub actions as possible. But trying to be smart, no left pad or this kind of crap. So This is my workflow overview. First, I will build a container. I have an app, I build a container because I want to deploy on Kubernetes. Then I will push the container to the GitHub container registry. Then in GKE, on the existing cluster, I will create a virtual cluster. I deploy the container to the virtual cluster. I run the test on the deployed container. Does it work for you? Yeah, looks nice. That's the easy part. That's my GitHub action. So you name it, and on every pull request to, for example, master, you run the workflow. Here, because you want to test it, especially at the beginning, you have this workflow dispatch, meaning that you can click and say, run it. So far, so good? Now, that's a bit more involved. First, you need to choose the parent image carefully. Here, I'm using Ubuntu Latest. Latest is a very bad idea to use. But again, it's a demo. I don't care. I will just get the stuff that works. You need to set up a couple of permissions because you will need actually to be able to push to the GitHub container registry. Okay? Depending on the level of flexibility that you want to have, you can define a lot of environment variable. I encourage you to use, and now it needs, yes, it works. You have this Docker build record detention days. This one is very important. It tells, like GitHub, how long does it need to keep the image. Basically, you want to keep the image a bit in order to download it to check that there is no crap inside in case it fails, but not too long, because afterwards, you will need to pay storage. And this is just for testing. Or you have another job that cleans the images. Up to you. And the first step is amazing. You check out the repository. OK. Now comes the fun part. You will need to push to the GitHub container registry. So you need to log in. I'm using an action that allows me to do that easily. I set the registry to, to the one that I defined before. So again, it depends on your level of flexibility. If you want to have a workflow that can work with different things or whatever. So here, of course, I'm using GitHub registry. The username is the person who actually runs the workflow. And the GitHub token is something that is done for you. You have it inside as a secret. So now, at this stage, I should be logged in into the GitHub container registry. Now comes the first problem. We will build an image, and we will store the image. The name is whatever you choose, but you need to choose a tag. What tag should you use? Sorry? Something with a snapshot, but if you use just snapshot, then two parallel pull requests will override each other. Yes? The version plus test. Again, if you have two different pull requests that use version plus tests, one will override the other. Yes? Sorry? Branch name, same issue. Same branch. Sorry? Commit ID. Commit ID is not a bad ID. So basically, we start to see the problem. It needs to be unique. But with the commit ID, if the test fails and you want to relaunch the test, you will override the image again. Sorry? Just build number. Build number would be if you assume that it's unique across your repository, then you can do as much as you want, but just build number would be enough. In GitHub, it's the GitHub run ID. And then it has a unique ID for each run. So you can be on the same PR. If you run the job twice, you will get two different IDs. If you want to fix it with a PR number so it's easier to check, you can do it as well. I mean, but at least you need something unique across all different runs. So you compute the Docker tag, and there is an action for that. So you have an action that you can use to compute the Docker tag. It also gives you some labels that you can override or enrich. And then you have this build and push Docker image. So you need to tell where is the Docker file. If you are using Spring Boot build image, then of course it doesn't work. So here it assumes that you have a Docker file. And something important, you perhaps didn't notice it, but here I not only have a name and an action or a run, I have an ID, so that on my next stage, I can use the output of the previous stage to fill some data. That's how you pass like information across steps in GitHub. So you give it an ID, and normally in the output, you should have tags and labels. You assign it to the next section, and you push. So at this stage, we have created the image, and we have pushed it to the container registry. And it was a fun ride so far. Now comes the part where I need to tell you still a bit about how Google authentication works. I'm not an expert. I regularly have issues. I had one issue this afternoon when I updated the demo. So just be nice with me on this part. It's not that great knowledge of my part. First thing, you have a service account. That in general works across like every provider. You have something that is not tied to somebody, but like a technical identity. Then you have what they call the workload identity provider, which manages identities from external identity providers. And then you have workload identity provider pool, which is the configuration for this external provider. So if I make it into a graphic, you have a role has different permissions, a service account may have several roles, then you have the workload identity pool that is tied to the service account, the workload identity pool provider, and finally the external identity provider. In our case, it's GitHub. Yeah, I'm sorry, it's the end of the day and it's not super easy. But I hope this graphic makes it easier for you. Now we will be using OpenID Connect, or IDC, for GitHub to send data to Google and to be authenticated via the service account, via the workforce identity provider. You need to map stuff. Basically, you just copy-paste Google subject equals assertion sub. So basically, GitHub will send this data, and Google will say, oh, this is this data. Lately, you need to set a condition. You need to set a condition, whatever that is, you need to set a condition. Otherwise, it doesn't work. It will just not validate. So here, and it's probably a very bad idea, I'm saying if the assertion actor is me, like Anne Frankel. Here it's pretty stupid. It's for the demo. I will be the only actor sending pull requests and like running the workflow. But if you do like this in your project, it won't work. So probably your assertion shouldn't be on the actor, but probably on the repository. So only like requests that come from this repository should be valid. And then anybody who has access to the repository and who has the permission on the GitHub side to actually create pull requests would be able to validate. Now you authenticate on Google Cloud using what we created before. So this, this is the project number, fun part. This is the project number because there is a project ID, but the ID is not a number. So you have, in Google, you have the project ID and the project number. Here is the project number. You have the name of the workload identity pool that you created, and you have the ID of the workload identity pool provider that you created. And finally, you have the service account, which basically is just an email. So far, so good? Well, you are brave, because this is really crappy. We are authenticated on Google Cloud. Now what we want is to be able to access the cluster. There is something that allows you, from the authentication on Google Cloud, to download the config that allows you to be authenticated on the cluster. So basically, this allows you to download a kube config. You set the cluster name, you set the location. Done. At this point, I would really advise you to check if it works. And if you achieve it on the first attempt, you can thank me. Because I didn't. So normally, if you just, for fun, try to get all pods here, this is something that you should get. Like, nothing has been deployed by you, but a lot of the pods, well, all the pods come either from the default Kubernetes setup, and here you have Fluent bits, then probably there is Google adding some pod for you, or a collector, probably an OpenTelemetry collector. At this point, it's already half the work. Now, as I mentioned, I want to install, well, I want to run in virtual cluster because, again, I want to benefit from isolation, from speed. So I install something called vCluster, made by Loft Labs. Very easy. We have one action to do that. But now we have another problem. When you deploy something using a manifest, you need to reference the tag. I remember we had this problem of, which tag should we use? Now we need to get it back and somehow to put it into our manifest. So we will reuse the GitHub run ID, and I will name the virtual cluster with the GitHub run ID. So that, again, for a single PR, if we run different workflows on the same PR, we have different virtual clusters. We don't step on each other. On the Kubernetes side, on the GKE side, we need to download the Docker image from GitHub. And now it's not free anymore. Well, it's free, but you need to be authenticated. So we need, in the workflow, connected to the GKE to create a secret to do that. Again, you copy-paste that. Very easy. There is something here. I don't directly create a secret. I do a dry run. I put it into YAML, and I apply the result. Sounds pretty stupid, right? Who has a clue why I'm doing this? In case the secret already exists, if I create the secret, I will get an error. Normally, it shouldn't happen, but just in case. Whereas if I kubectl apply and the secret already exists, well, it will just overwrite the stuff and everything will be good. So it's just to avoid stupid stuff. You need to create every configuration, map, and secret that you will need on the Kubernetes side. Here, I'm using a config map for the database that I will set up. You can create secrets as well. You do whatever you need to do. As I mentioned, I'm using Postgres. I will need to set them up. Then I install Postgres. You install Redis. You install whatever you want for your tests. So now comes the time when you need to update the manifest. Again, as I mentioned, the manifest is static, but we have a tag that is dynamic. We have two ways to do that. The quick and dirty way, which works perfectly, or the cloud native way. I let you decide. Cloud native way is first you create a customization and you basically replace this like tag with the GitHub run ID, and then you apply the manifest with the like -k, or you just like set everything and you apply the manifest. I would encourage you, if it's super simple like this, to use sed, because customize doesn't add anything in this case. If it starts to become more complicated for whatever requirements you have, then yeah, customize makes a lot of sense. Now, it's deployed. We have the database. We're in a very good position. We just need to access it from the workflow. In order to access a pod or a deployment or whatever, you need to have a service. In order to like expose the service to the outside world, it needs to be, let's say, something of a load balancer. On the cloud, it makes a lot of sense to have load balancer. You don't want to have node ports or whatever. So you just get the public IP from the GKE instance. Make sense? Doesn't work. Because it's not instant. Google doesn't just give you an IP and you are good to go. Takes time. Needs to find one that is free, to assign it to you, do all the network stuff. So it's more like this. Like, get the IP. If the IP is not set, then wait. Get the IP. If the IP is not set, wait some more until, well, you have enough of waiting and it's timeout and probably something is wrong, or you get the IP. I would really encourage you, because it doesn't cost anything, just write it down in the log, so you will get it in the GitHub workflow log. Good. What's the last problem to solve? We need to wait some more, because now we have the IP, but how do you know that actually the pod is ready to respond? Nothing. So if you continue the workflow, it doesn't work. We need to have a waiting step. Again, two ways to do that. That's the way that I found super smart. You have basically something called wait for X. It waits for a lot of different conditions. It can wait for a database, for like message queue, for whatever. And you run it as like a Docker container. And you say, until this container is not healthy, then yeah, you just wait. You can have a timeout as well. And then on Reddit, somebody told me, hey, you are an idiot. There is something for that called kubectl wait. I never used it, but I mean, if you are like very good, you can tell whether it's better, one or the other is better. So here, let's say I'm waiting for Postgres, and I will wait until it's ready. It has run. What do we need to do? Clean up. So we will delete the virtual cluster. So let's delete the virtual cluster. Done. Nah, you don't seem convinced. You feel there is a trap. There is a trap. The problem is it doesn't work like this, because if you are trying to delete something, let's do it first. Like here, what happens if the thing failed before? if it failed before you actually created the virtual cluster. This will never run, which is not what you want. So if at any points in the workflow, for example, if the integration test fails, it will stop the workflow, and this step won't be executed. So every test that fails will leave you with virtual clusters. You don't want that. Hey, you are smart. I always want to delete the cluster. Yeah, but then what if it failed before it created the cluster? This step will fail as well. So now you need to be like super smart and say, yeah, the expression is super stupid. If always, and the conclusion of the vCluster step was a success, basically I successfully created a vCluster, then I do this step. Yeah, the semantics is not amazing, but this works. Now, demo gods, please. See? This is this afternoon when I changed the configuration. This was before. This was my first talk. Why didn't it work? I ran it afterwards, it worked. This was this afternoon when I changed the configuration with all the Google authentication. And I say, oh, it works now. So let's do it again. Are you ready? I mean, at this point, even if it fails, I can say, hey, it worked there. And everything is on GitHub. So basically, if you don't trust me, you can check by yourself. Wait until it's green to take the picture, please. I would really appreciate that. And everything will be in the last slide. So, I can show, well, here, check out the repository. I installed the Jerry because it's a Java app. Here, what I'm doing, I'm also doing a bit more. I'm also running the unit tests. Why am I running the unit test? Because if the unit test fails, why should I run integration tests that are more expensive and slower and more fragile? So that's a good thing to do. Normally, they should be not unit tests, they should be fast tests, but break, fail fast. Then, as I mentioned, I set the GKE credentials. I edit the image tag with GitHub run ID. Here, I have slightly changed the order in which I've presented you the stuff in order not to wait as much as I would need. Now I create the vCluster. For example, the vCluster creates a bit takes a bit of time, so I prefer to do it first. And then I do the connection, and once I'm there, I will get the credentials from the virtual cluster, not from the host cluster. See, it's in its 0 on 3, 2 on 3, 2 on 3. It's like, normally it should take about 1 minute to create a virtual cluster. And you can see it, I'm running with time. So basically it should get the information from here. Don't make me lie. 1 minute, 15 seconds, okay. It's around what I'm connected now. I schedule the Postgres. So basically now Postgres is deployed on the virtual cluster. Now it's the time where I actually am doing the stuff with the builder. I'm logging into the registry. I have the metadata. I'm building the image. Here probably you should use some caching layers so that, well, you optimize the writing of the image. If you are really, really good with this, you can also do some stuff in parallel, like you can set up the Google container and do the build like in parallel and just join afterwards. Oh, look, I'm already like retrieving the load balancer external IP. And look, how many, yeah, that's, so I think it's 10 seconds. So basically, I've waited for 30 seconds, and I still didn't get the IP. So if you just try to get the IP or like in one go, it will never work. 40 seconds. I think my loop is 10 times. Yeah, 10 times. And where is it? 10 seconds. Yes, I have it. And now I'm running the integration test. Oh, it has worked. It's amazing. Build success. Test run 1, failure 0. And that's my second talk, and that's the first time where the demo works. It's amazing. Okay, and here, as I mentioned, you need to delete the vCluster in any case. Something that you might want to do, for example, is keep the virtual cluster in case it didn't work to check the state. So in that case, of course, then you would change the step accordingly, like not if always, but in case the test didn't succeed, you want to keep the stuff. And now you have all the post stuff, and now you can take the picture. Take the picture. Take the picture. Thanks. To be honest, it requires a lot of engineering skills and a lot of luck when you are using cloud infrastructure. Anyway, that's what I wanted to tell you. Two things, if you want to improve what I've shown you, you can provide a better base image. Here I'm using Ubuntu latest. It's probably too big for what I'm doing. So if you use a smaller image, if you use a smaller image, it would probably be faster. And use caching as much as possible in your pipelines. Use caching all the way. So thanks for your attention. You can follow me on Blue Sky, on Mastodon, and if you really need, on Twitter, but I'm not using it a lot anymore. If you're interested about the written parts, I have written it in 3 parts. You can have it on my blog. And if you're interested in the code itself, everything is on GitHub. It's just protected by a bit.ly link, so I can check how many people did actually open the link. And it's not a lot. So I'm wondering whether demos are actually good things or not. How long do I have for questions? Where is Marto? Marto? No, Marto is gone. Marto is gone drinking beer. How long do I have for questions? 10 minutes. Ooh, amazing. So you have 10 minutes, or you can have beer. What do you prefer? Yes. No, it's not. You should avoid it. If you use Node-POR inside the Google infrastructure, you will never expose it to the outside world. I mean, that's the point of the load balancer, is you expose something from an hyperscaler to the outside world. That's exactly the object that you need to use. So my point is, if you use it, you can use it, but you will never see it from outside. And here we need to access it from GitHub. So we need to have something. Other questions? Bira. Okay, thanks a lot, and enjoy the evening.